In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time, causing chaos and disruption. The world needed a hero, and Miller was ready to answer the call. With his flute in hand, Miller played a tune that echoed through the cosmos. Each note, a shot of pure ether, struck the Einsteinian demons, dispelling them back into the void. The world was saved, not by a warrior, but by a musician, a scientist, a man with a flute. Remember, in this universe of wonder and mystery, sometimes the most unlikely heroes make the biggest impact. Keep your mind open, your heart brave, and who knows, you might just find the ether within yourself. So here's to Dayton Miller, the flute ether master.
All right, lads, we're about to go live here. My apologies, Flat Earth Fridays had a last-minute cancellation. Shout out to Sacred and Proud. Sacred's going to a funeral, or had a funeral today, so no Flat Earth Friday today. He's taking the weekend off. I'm going to join the community-hosted space by Nicolas Cage and some of the level heads over here co-hosting. Shout out to the boys. We're going to see what the lads are up to. Forewarning, my internet is lagging pretty hard tonight. Should I disconnect super hard, you can always check out Shane's stream. He'll be hosting or streaming it all night.
If we realize that the community is getting smaller, well, maybe the message isn't getting up. Like I said, I'm not.
Oh, it's only gotten bigger since I've been in the game.
So
Ralph, you don't find it weird that they say that a ball is somehow tilted and we can tell it's at 15 degrees. It's also spinning at 1,000 miles an hour and orbiting the sun at 66,000 miles an hour. And we're also chasing it at 500,000 miles an hour, and we can't feel any of that. You don't find that weird?
No, well, I mean, we're all in relative motion. So just the way I'm saying, you'll
still feel it. I realize that you're not being pushed back in your seat with constant acceleration, which is what we're actually doing with 500,000 miles an hour, but whatever.
Wait, are we always speeding up and speeding down, or is it a constant speed?
Dude,
allegedly.
We're going in 3 different directions at the same time.
Okay, but is it at a constant speed, or is it changing speed?
Dude, we're going 1,000 miles on a spin.
Not arguing that fact with you, Brian.
We're going
I'm not arguing that fact with you.
Dude, we're going 3 different speeds and 3 different...
But is it a constant speed?
Dude, we're going... No! None of it's constant.
No.
There's 3 different speeds. What part of that is constant?
What part of...
You're not really understanding what I'm saying. What I'm saying
You're
is,
not
are we speeding up or are we slowing down?
In 3 different directions.
Brian, it's very easy, my guy.
Bro, my guy, you're not listening to me. We have 3 different speeds in 3 different directions. How can that be constant?
So we have 3 different speeds and 3 different directions. That's what you're saying, correct, Brian?
It's all claimed speeds.
And dude, that's not even putting in the
Let's refine it even more. You're claiming that the claimed information that we're moving at 3 different speeds at 3 different directions. Is that what you're saying?
With a wobble in there. That is the claim.
Okay, that's the claim. Okay,
that's more than that. When you're moving in a circular motion, it's a constant acceleration. Acceleration is changing speed or velocity, and it's always changing velocity since you're going in a circular motion.
Okay, but are we speeding up? Are we slowing down? Or is it
we're changing velocity, which is speeding up in another direction. It is a constant change in velocity. It is a constant acceleration. If you're on a merry-go-round at the park and you're on it going at constant speed, you feel it, bro. Because you're constantly changing direction, which is changing speed, just not the speed you're thinking of as the horizontal speed. Yeah, we're traveling relative horizontally, but if we're also spinning, that's a change in acceleration, or that's a change in acceleration right there. That is acceleration. I'm sorry.
You explained it perfectly. We're on a merry-go-round. The merry-go-round, is it going at a constant rate?
Right. There is no, it's not, because if on the surface of it, if it is in fact spinning, it is in fact changing direction, it is in fact accelerating.
But is it at X amount of rotations per minute, or is it speeding up or speeding down? Is my exact
No,
question.
it appears to be a constant motion, but if you're at any one point on the ball, you will be constantly changing direction in a circular motion, which is not a constant speed.
Constant rate. That's the only point that you guys are not ignoring, or maybe I'm not making my point clear. I'm not arguing.
Have you ever been on one of those, Ralph?
Hang on, Nick. I'm not arguing the speed. I'm not arguing the direction.
I'm just asking.
Have I been on a merry-go-round? Yes,
no,
I have been on a merry-go-round.
One of these swing things that he's talking about.
He was talking about a merry-go-round.
No, I think he was talking about. Didn't you say the swing there? Did you say merry-go-round?
I'm telling you, anything that is turning, you can get in your car and drive at 10 miles an hour in a circle. You're constantly accelerating. There is no relative. We're not moving. You're constantly accelerating in a direction.
Exactly. But you're maintaining 10 miles per hour as you're turning.
Correct, and it'll work linearly how you explain it, but it will not work in a circular motion.
That's why we don't feel it, because it's a constant rate.
If it was a circle, we'd feel it, and it is a circle. You say, don't you get that?
You know what? Maybe I don't get it, and I'll give you guys.
If I'm going straight line,
because it's a constant rate, is why we don't feel the change.
Listen, if I'm going constantly a straight rate in a straight line, there is nothing to feel. Now, if I change directions, I just accelerated. And if I'm constantly changing directions, I'm constantly accelerating. This is like basic stuff, dude.
Not arguing with you any of it, but what I'm saying is, yeah, we're agreeing. It's a constant speed. It's a constant rate. That's why we're not feeling this. Like we ourselves are turning, and we're turning with the Earth.
Right. So if you get in your car and drive 10 miles an hour in a circle, you don't feel like you're pushing against the door. That's bullshit.
Well,
you do.
Well, now you're trying to apply a very macro observation and feeling.
The acceleration, no matter how small, is still going on.
I mean, I understand what you're trying to say, but it's not enough. You're not saying it. It's not enough for me to be like, oh, okay, yeah, flatter.
Well, no, it's not. It's not subjective. No. It's objective that you are constantly accelerating when you're in circular motion, no matter how minute.
At a constant rate. I mean, it's that, and I'm not in a car turning. The Earth.
Okay, the exception is to circular motion. You gotta remember this. It's an exception to the rule. Circular motion is a constant acceleration. You're constantly changing different directions. You're not constantly going in any direction. You're not constantly going 10 miles an hour in any one direction. You are constantly changing your direction, which constantly gives you acceleration. If you weren't constantly every second changing your velocity, you wouldn't be accelerating. But since you're constantly changing, every split second you are changing direction. It is a constant acceleration. It can't be argued. It's not subjective.
Yeah, I think you'd feel that.
I mean, he properly explained it. I just don't think it's good enough an explanation for me, but who the fuck am I?
No, it's true. You're saying it's not applicable at the scale of the Earth. Because the degree that it's changing every second isn't enough. That's what you're saying, to feel.
Yeah, you explained it a lot better than I did. Absolutely, yes.
So you still think you're spinning, orbiting, and hurtling through space?
Do I think it? I think it. Am I hanging my hat on it? Like, this is what matters? No, it doesn't matter. That's like the bottom of the list to me.
It's not just the Earth neither. So the Earth's spinning, and then the Earth's going around the sun, and then so that's the three directions he was talking about, and so all those three are constantly accelerating in three different directions at any given time.
Not to mention the three different gyroscopic motions wobbling on three axes, right? You get nutation, precession of the equinox, obliquity of the ecliptic, all blaming on different axes of a motion of the Earth. So you not only do you have constant and different acceleration in a multitude of directions, you have three different axes around which to rotate. So go ahead.
But it appears like we're stationary.
Can I add that they already know that we don't wobble on our axis because it's presumed that we do because of the precession of the stars. But if that were true, the planets would also precess, and they don't. So they've known for a long time that the evidence for wobble is not there.
I would think we would feel the wobble, man. I mean, we feel earthquakes and stuff. I felt the guy drive by my house with a loud muffler.
Hey Nick, real quick, or Ken, I can't get Liliana up here. I don't know if you guys can get her.
You know,
There's a
she
request.
mic request.
I
I sent her an invite.
So did I.
Liliana, click on the mic and then unclick.
You know, this is only proof that we totally made phone calls to the moon.
Yeah, it looks like she's
Hey,
sleeping.
I'm gonna leave y'all to it, fellas.
Well,
Thanks for coming by, Eli. Always glad to see you pop in, brother.
Yeah, thanks for
Peace,
coming.
Eli.
I wish you could have. Wish Tom could have stayed around.
Nick Cage, I got the moon on line 1. It's for you.
It's for me.
Yeah. We got a couple of guys up there playing golf. They got something to say about America. A little message for their captain in chief. What do you got to say, Cage?
Hey, yo, keep it going, man. Get that iron out. Come on, man. Phone calls to the moon. Ain't nobody making no phone calls.
Liliana, if you see a mic invite, just give me a thumbs up. If you don't, give me a thumbs down.
You might have to refresh the app or something. I don't know why she always has issues.
How dare you speak of Madam Ambassador of incompetence and blame her? It's clearly technology's fault.
I know. It's Elon's fault.
She is trying to make it all happen on her phone.
I feel you, Lily. That's all I use is my phone.
Oh,
There she
hey,
is.
Hey, there
can
we
you
go.
hear me? Yeah. Sorry, I
There
don't
you
know.
go.
What's up, Lily?
Sorry. Hey, how you guys doing? I'm so sorry to hear about Sacred. That was really sad, but I'm glad that we can still do a space together.
Wait, what?
Yeah, Sacred.
Hail, the gang's all here.
Yeah, Sacred had some personal issues.
He's not hurt, right?
I don't think so.
No, he was just at a funeral.
Yeah, he's not with it today. He don't
We're
have
taking
it
a
in him.
personal day. I think we shouldn't get more into it and, give him a little bit of privacy, respect, keep him in our prayers, but he's taking a personal day.
Yeah, pretty much. So hopefully everything is going all right with everybody else. Welcome. See how long we can last. Been going since early this morning. I'll do my best.
Wait, Nick, you've been up since like 5 a.m., bro.
Dude. Yeah, it's crazy. So, but, I got some meth. See how long I can hang out. There we go.
Yeah, little birdie told me that Alan may be falsifying time dilation.
Alan's doing well. What?
Someone said time dilated?
Are you dilating?
Yeah. I heard you.
10 or 12.
You might have something on that.
Well, I've never experienced any. I know that.
I have. I got real high this one time, and it felt like an hour, but it was only 10 minutes.
Dude, you ever been driving in your car and then be like, damn, how'd I get here?
You go autopilot, like your brain kind of clicks off, and then you're like, what the fuck, I'm pulling in?
Oh yeah, I've been
You're
there.
talking about when you dissociate from reality, you just autopilot. Yeah.
You're like, how'd I get here? Oh yeah. So I think there could be some time dilation there, man.
We've entered a temporal pocket.
Could happen.
Ooh, speaking of temporal pockets, I have an ad read here for Ether Hot Pockets. Let's see.
Yummy.
We now have a new flavor. It now comes in neutrino. So it doesn't taste like anything, but it somehow provides the flavor for everything. So that's very cool. You guys can check that out on etherhotpockets.com.
Is it packed full of quantum foam?
Ooh, no. We use no quantum foam in our Hot Pocket, Ether Hot Pockets.
All right.
I find it kind of has a taste sort of like a wasted career.
You can taste the despair and dead dreams of a person that holds a piece of paper with the highest regard possible.
So it tastes like string theory.
Oh my.
Yeah. It tastes like math. Like, you know, when you what's that, you know, like SpaghettiOs or whatever, but the ones that have letters and numbers and stuff. It would be like eating that, where it just doesn't have any flavor, but it like represents a thing. And you're like, oh man, this tastes like 4, but it doesn't have any flavor. That's what it would be like.
Hey, Nick, earlier, do you remember just like, I don't know, half an hour ago, you guys were talking about the gas giants and then something about all the, you know, the gajillions of miles of, you know, the zillions of miles and the light years and this and that. We should compile like a bunch of all these things that are so obviously ridiculous. And after each little point, you know, each little issue that's ridiculous, we should have like a combination of real laughter and canned laughter. I think that would be a really nice little audio meme kind of a thing. Because I was laughing, you know, when you guys were saying that.
Well, somebody said that an asteroid hit Jupiter, and I was like, "How's that even possible? Wouldn't it just go right through?"
Yeah. Ouch.
Wouldn't it just—it's a gas giant. It should just go. Poof.
You don't understand, Nick. It's the
Yeah,
gas
I mean,
is
yeah, you're
so
correct, Nick.
dense. It's liquid metal.
It should have blown it all apart, man. If it could have wiped out the dinosaurs, man.
Well, I mean, what they're gonna say is, yeah, it penetrated the outer fucking surface of the planet, but then as it got closer to its core, you know, gravity just fucking imploded it.
What
I mean,
is
if I was gonna give you a
what
sciencey
is
answer,
causing
that's
the gravity
where
on
who
a,
would fucking go. What's up?
what is causing the gravity on a gas giant?
Well, if you go to fuck, what is it? Newtonian? You know, mass. You know, the bigger the mass, the bigger the space time displacement. But if you go for ether flow, the larger the mass, the greater the ether flow, and the
What's
greater the gravity that's caused by the
what's the
ether
mass
flow.
that all the gas is attracted to on this gas giant?
Well, I mean, look at the sun. The sun, for all intents and purposes, is a gas
Oh,
giant.
I'm there too. What's going on with that sun?
Well, it's fuck. If my understanding is correct, it's layered from what's happening in the middle versus what's happening in the core versus the outer versus
What's the sun
the
made?
mainly hydrogen. If I'm correct.
Yeah.
Oh, hydrogen and helium apparently, but how do they verify and validate that?
What's the purpose?
What I'm assuming is probably, and I'm gonna get this wrong, radiotopscopy.
What happens?
I know,
Is there some?
Alan knows that.
Spectroscopy.
What
There you
is?
go.
Does helium and nitrogen combust?
Nitrogen, I believe no, I don't believe so. I believe nitrogen is an inert gas. I think helium may be under enough fucking gravity. You know, it could, but what do I know?
Seems weird that we got a big old giant ball fire of it.
What's fucking weirder is what I found out the other day. The photon that's created at the core of the sun doesn't get to the surface until a million years later. It's like, well, how the fuck do you even come up
Oh
with that
no,
calculation?
Ralph. They got
Right,
you
like I
with
heard that one, and I'm
one.
thinking about it, I'm like, wait,
Are you
I'm
questioning?
like, how would you even know the age of a photon? Like, how would you even be able to extrapolate that type of information from, the
Are,
data we collect from the sun? So
are you
that's
doubting?
weird.
Are you doubting science?
It's
Am
a,
I doubting? Doubt everything. The fuck? Everything should be doubted.
You should
That's the
definitely.
entire point of science, to
Is that
disprove
where
it
is
and
that
do
where we're
better
at?
science.
Did we reach the limit of bullshit you'll believe? A million years? How could they get a reference point on that?
Yeah,
hey,
exactly. I will
Nick,
concede to that point. How do you get a reference point that the average person would be able to wrap their heads around?
So
And if it's not
this is
something
where
that
we
the
reached the
average
limit
person
with
can
you,
do
Ralph.
it, then does it even
This is the
exist?
point of science where you're like, this is kind of bullshit. There's no way.
No, I'm not going to say there's no way. Just because I don't understand something doesn't automatically make it a lie. I just don't understand it. It's on me. It's not on the thing.
What was that, Alan?
I can't remember. I think I was gonna say that's when you hit one of those cracks where it's just like you hit that limit when you like at least you have a limit, and then when you hit it, like that's where it's like, okay, do I need to am I gonna re-examine this, or am I just gonna accept it and ignore it? That happened to me with gravitational lensing. When I first heard of that, I was like, wait a minute, you're telling me you can just see forever now? Like just and that's exactly what it was. It's like, cool.
I mean, I could kind of understand gravitational lensing just because, there's like pictures that could more or less describe it. But the million-year-old photon, I I have no way of getting my head around that one. So that one to me is more than suspect. I mean, I don't know. It's too much cream on the tacos. Like there is no fucking point of even having that piece of information. What the fuck do I need to know if a photon is a million years old before it leaves the sun?
Has
But
anyone
that's just my
a
personal view.
photon? Just out of curiosity,
Have they what?
has anyone ever seen a photon?
I've seen clips on YouTube where they videotape or record with super slow motion a single photon.
Yeah, right.
Yeah, I mean it's up there. I mean, take it for what it is.
Ralph.
Is that an indirect or direct observation?
I believe
Fabrication.
it's a direct observation. I mean, shit. Let me find.
All those observations of atoms and such are indirect observations, and we apply
Do they-
names to what we observe and interactions with things that we can actually observe.
Do they observe it with the photons flying off the photon? Is that what the picture is of? The photons that hit the photon and fly towards you?
Oh no! This is a video. This is live motion. This is not a series of.
I know, but I mean, the photons hit it and then go into the camera.
No, this would be a side view. So if you're into video games, it would be a side scroller.
These are different
There
photons.
has to be some kind of equipment that's not a lens. Then
I'm just glad that seeing a photon takes a million years to get to the surface of the sun, and we figured that out 93 million miles away, and then it takes its million years lifespan there and ends it in 8 minutes on its travel to Earth, and that's where you're drawing the line of I'm going to start questioning this shit. I'm just glad we got a line.
Same.
Dude, do you guys remember like 30 minutes ago when people confidently told us that, geodetic surveying was measuring the curvature? And you guys remember what happened?
Oh man, I had that in my YouTube comments all morning, man.
Are we still going with surveying?
Who tried to survey you? Show us on the Seattle where they corrected for the stars.
I was just reminiscing fondly, Like,
Guy
that was
named
fun.
Foolish Tom.
Yeah, where did Tom go?
Yeah, no, he disappeared. He called me a thief, and then he said shame, and then he tried to shame me a couple more times, and then he left.
Oh,
Yeah, I don't that. Oh, shame. It's like it's just observation.
You know that Game of Thrones theme? It's like shame, ding, 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 shame, ding. You know what I mean?
What did you steal, by the way?
Well, I threatened to steal an Earth curve calculator. I'm not going to say from who.
Oh, I dare you, Shane. I dare you.
Would that be the same open source public domain one, or is that a different
It would
one?
indeed. It would indeed. Yeah, I was thinking about it. I had my eye on it.
Oh, well, you
And
can
his
steal it
name
if it's
kind of-
already yours.
And his name kind of rhymes with altered biscuits.
Yeah, but only if you're from Germany, I heard.
Only if you're from Germany.
Otherwise, those translate doesn't rhyme, right?
Are you talking about Flolter Flislin?
How dare you say his name? He's the holier than thou. Listen, I'm gonna go on a crusade to protect his righteousness. You better not disgrace his presence, the great one.
Nah, he's talking about Walter Wislin.
Oh, fuck that clown. Who gives
Ah,
about that clown?
the
Okay, so let's put
second cousin.
let's put a pin on the little hate bash for a sec. It was a laser pulse that they recorded the photon. Linked the video at the purple.
Nice.
Let's check it out.
I mean, even the like I said, I didn't know we can go this high, but to capture a photon, it needs to be at 1 trillion frames per second.
What's a photon, Bell?
Just a
What's
straight
photon?
trilly?
Did
Click
you
on
say
the
tri-
YouTube video that
No, they say
Ralph posted?
no, they said 6
You-
trillion.
You
Did
should
you say
cop that photon?
They said 6 trillion to pop a photon. Thank you
Oh,
very much. Al. That's the new one.
6 trillion. My bad. My mistake. Yo,
6 trillion.
I see Barber Dan with his hand up. Yo, you can jump in, Barber. What's up, dog?
Yeah, I've got one for Ralph. Ralph, so I'm going to give you the benefit of the doubt, right? If we go by mainstream and modern science's definition, right? Can you tell me why, by all of the observations, the 3 elements that all connect to each other from the sun, the moon, and the earth, uranium, thorium, and deuterium,
That's
how
crazy.
do you suppose that they're not connected to each other?
So thorium and then the other 2 elements. You're asking me how they're connected?
No, how do you suppose that they are not connected to each other? If all
Oh.
3 elements have been found in all 3 locations.
I mean, shit, that's a great question. I don't really know enough about the subject to give you a good answer for it. I mean, but how often do we find different mineral deposits, amongst each other? I mean, so
So
does it happen? Yeah, it does happen.
hear me out then quickly, right? So the story goes that the moon is a cold star, right? And the conversation we had earlier, what I said about the Earth's core being molten uranium. So what if the sun is a uranium fusion generator that is an active uranium fusion generator, and that the moon was generating fusion, but it ceased to be able to create the energy. So it's actually charged moonlight, but it's charged via the ether within the radioactive spectrum of uranium.
Shit, I don't know, Dan. That's I'm gonna be real with you. That's way over my pay grade. Yeah, I don't
No,
have
it's
the
not.
depth
No,
of knowledge
it's no,
to properly give you
no.
an answer.
That's just an excuse. To me, that's just a mental cop out. You're saying it's way above your pay grade. It's
Well,
not
I don't want
above
to say,
your
okay,
ability.
well, you know what, maybe that's
But
the reason why I don't have the tools of knowledge to properly.
Let me finish. It might not be above your pay grade, but it shouldn't be above your thinking grade.
Dude, was that a mic drop or did I lose audio?
No, I mean, hold on. I thought we were gonna have him describe what a photon was. That could be fun.
Man, I was up there changing the title and I heard everybody go silent. I thought, man, did I crash the space or something?
Well, you made it space is fake and gay, so yes.
All of a
We're
sudden, everybody went
certainly
silent.
crashing. Just
Can I take Ralph back to the sun for a minute?
Please.
Please.
Hey, Ralph, you mentioned Newtonian, so I'm guessing you kind of know the guy a little bit.
We partied a little bit.
Okay, so you're, I guess, at least partially conditionally subscribed to the old mass attracts mass thing.
Oh, let me stop it right there. No. If we're talking about
You're not?
gravity, I'm starting to support ether flow as the cause of gravity. Let me stop you right there.
Well, that's a kind gesture. Cool.
What's happening?
Let me take you through some quantification of what I was seeing a while ago, just for kicks then. Because we were talking about that sun thing, and it's a question where somebody asked you, what's it made of, and you are guessing hydrogen, because it's so big, and
Guessing
that's all
correct.
cool. Well, it could be lots of things in there, but it's the mechanism by which it's burning. They all talk about how there's some fission going on there. Are you familiar with that?
Yes.
Okay, great. Even some fusion farther down inside, right? Because there's more pressure, more gravitational mass going in on each other, and they're exceeding what they call the first Chandrasekhar limit. Are you familiar with that term?
No, I am not.
Okay, not to worry, but that's the one they're talking about, I think. It's that one that turns a gas giant into a star. There's this critical mass kind of thing going on where eventually things are just so freaking dense. There's just so much pressure, molecule to molecule, that they just kind of break against each other and cause fission. And that's what's happening supposedly to all that hydrogen in there, right? But
Correct.
okay, so when you take one step back from that situation a little bit and you look at the Newtonian thing and you compare it to the numbers they've applied to Earth, the old 9.8 thing, I'm sure you've seen that one a few times.
The gravity constant on Earth.
Oh, we just
a
did
little
it for the
bit.
moon. He's very familiar. Yeah.
Right. So the moon is 1/6 because it's got less mass, and those are two allegedly balls of rock, right? So they're pretty small compared to the sun. But did you know that when you start to apply that same math to the sun, at what people say is the radius of the sun, where the surface begins of the sun, when you start to run those Newtonian figures and compute G for the sun, you find out that at that radius, where they say the surface is, it's only about 32 Earth G. And my question is, where's all the pressure that's causing fission? Because I don't think we're going to do it with 32G. I mean, it takes 9 to knock a human out. That's not very much when you're talking about banging molecules together, right? Just where exactly is this spark? Where is this force? Where is this limit in the actual numbers that they use to produce or initiate fission? And forget fusion. Just the first line. Get over the first finish line here. I'm hoping by now, Ralph, that you can see that their own numbers are just so far from adding up in any coherent way when you look at cause and effect and the asserted analysis. You know what I mean by that?
Well, I'm okay. So you said 29G. Is that on the surface of the moon, or is that at the core? I mean, the surface of the sun, or is that at the core of the sun?
What I was specifying was the radius of the sun, as in where they think the surface is. Where when we look at it from here, boy, 93 million miles away, the edge of the sun is so well defined, isn't it? Yet it's a gas in a vacuum. But somehow,
okay. So once
32,
again, so the surface,
not 29,
the surface gravity
not
of the sun is
29,
what?
not 29, but 32 Gs roughly compared to Earth is supposedly holding all that together and producing fission at the same time. Isn't that amazing how it does that?
Is it the same gravity at the surface of the moon versus the core of the moon?
We're not on the moon, Ralph. We're talking
I
about
mean,
the
I'm
sun.
sorry, my bad. I don't know why it's the same moon. Is it the same? Okay, is 39G, is that on the surface of the sun or the core of the sun?
Okay, it's not 29 and it's not 39 either, Ralph. We're talking about 32.
Okay,
Write that one
32G
down.
is well, it's because I'm looking at it online and it says it's 29. But I'm
Well,
just
yeah,
going with your number.
okay, 29, 32. Let's
Yeah,
just say it's
exactly.
somewhere
There's those
around
numbers,
30.
but my very specific question is the gravity that you're referring to, that number that you gave me, is that for the surface or the core of the moon? I mean, of the
Once
sun.
Again, we're not on the moon, we're on the
Is
sun.
it for the
And
surface of
I
the sun
keep
or the core
saying,
of the sun?
the radius and that the edge of the sun, when we look at it from here, is so well defined. The edge of the
Stone, I'm
sun.
asking you just about the gravity, just about what you said about gravity. That's it. I'm not touching anything else other than that section. You said the surface of the sun is how many gravity?
About 32 times that
Okay,
of Earth.
would it be the same for the core?
No, at the core, it would be 0.
Meaning less gravity? Because that's how I'm interpreting 0. Or would it be just that much gravity that the only number they
No,
have for it is 0?
that's the point, Ralph, that if all the mass is around the core, the very
Mm-hmm.
barycentric, forget the actual barycentric, the physical center of the sun,
Mm-hmm.
that little place that is like,
Mm-hmm.
if we carved out a spot in the middle of the sun the size
Mm-hmm.
of you and stuck you in there with a gravimeter,
Mm-hmm.
you know, a gravimeter is, right? It
Measures
would
pressure, I'm assuming.
it would actually register 0 because all of the mass is around you in all directions. It's canceling out. Do you see again how the
So
model
that
that they,
0, okay, that 0 rating, how far out from the core does that propagate?
it's only 0 at the core.
Okay, so then directly above the core, it's higher gravity?
You mean slightly farther away from the core. In all directions, it's slightly higher gravity. And as
Okay.
you go towards the surface, yes, gravity increases to 32 times that of Earth on the surface of the Earth comparatively, on the surface of the sun comparatively. You know what I'm talking about? You with me now?
Okay, so what you're saying, just so I understand you properly, is at the very core, it is 0. As you get away from the core, it starts ramping up from 1 all the way up to 32 once you get to the surface. Am I understanding you correctly? Should I drop down and come back up?
Will that make you smarter?
Did you hear Ralph Stone?
Sorry, I just had it on mute there. Yes, what we're talking about here is an order of magnitude, that it's either 20, 30, or 40. Who cares? It's a span anywhere in there. That order of magnitude is absolutely nowhere near the order of magnitude of inward force required to produce freaking fission.
So that means we don't understand the sun 100% as much as we should, and we have a lot more to learn. What about that is going to change anything to do with what we're talking about right now? Like, I'm not even understanding that part. Yeah, and
It changes
help me.
absolutely.
Obviously, your
Ralph,
intellect is that much higher. Help me understand. I want to understand. So don't laugh
great.
at me. Work
Then
with me.
stop interrupting me if you want to understand. Okay. What it changes is our perception of the validity of anything people in the mainstream science sector are saying about the sun. That absolutely everything they say about it, when you put it all together, it equals absolute nonsense.
Okay, so that sounds like a lot of opinion. I can agree that mainstream science is held back because of a lot of profitability that they want to, either create scarcity to create profit, or they're just trying to create profit through, misdirection. I agree with that. There's no problem with that. But what does that have to do with the shape of the earth, which is what we were on?
Okay. You understand that it's the same people who are
Government lie,
making.
government bad, science people lie. There's a conspiracy. People do shit for money. Yeah, I'm agreeing to that. I'm not oblivious to that. I am
Okay.
100% with you guys on that. But
So
that
then
still
you
does
can
not
see,
defeat this still does not defeat the flat, or still does not defeat the globe model. I mean, it's I'm happy to hear something else, but that particular thing that you said, Stone, that you so eloquently explained to me the way I couldn't, didn't do anything for the argument.
okay, well, it's just that you're not recognizing what it, quote, did for the argument.
You know
And
what? That's another thing. My intellect is not smart enough yet to
yeah,
properly understand and put all the things. I'm cool with that too. I'm just your
you're
average guy.
kind of failing to grasp the significance of what I'm laying down here, Ralph. That's
No,
partially
what
the
you're trying
problem
to
here.
say, and I'm just making it very blunt, is the government lies. The mainstream academia has a control on information, and they're lying. Yes, I'm agreeing with you. That's nothing new.
Right. But you totally believe them when they tell you the earth is round.
It's not them that's telling me the Earth is round. This
Oh,
is like
it's the
just it's
same. People
history.
talk about the sun, Ralph. They're talking about
No,
the sun. They're
then
talking
okay,
about
but
the
if we
moon.
really
They're
want to
talking about
talk
the
about
earth.
organizations who have a longer history of lying, they use a different model than the globe model to lie about.
I don't know what you're straw manning about now, man. But what we are
No
talking
worries, no
about.
worries. We could just pass it on to somebody else. I'm good.
Okay.
I don't know what you were
Would-
spending on that either, man. But I gave.
I can elaborate if you want, but I'm willing to let somebody else talk. I'm not trying to take up all the time.
I only take exception to your assertion that you were just hearing my opinion about what I just contributed here.
It's well, unless it's
Ralph,
fact, yeah,
fucking
it's opinion.
stop
I'm good with that.
interrupting me for the love of
No, bro,
spaces.
because this
Stop
is just
fucking
exposition. I'm not
interrupting
here to
me.
hear fucking exposition.
Stop
Let's just move it on.
fucking interrupting me,
Let's just
Ralph.
move
My
it along. You're
God.
not. This is not creating any benefit for the.
I let you speak, you
Bro.
let me speak. That's how it goes in the sandbox. Okay, buddy? Come on,
This is
man.
you and him, Ralph. Everybody else wants to hear this stuff too. Go ahead, Stone.
It's just so far. Seriously, Ralph, just a little bit of reciprocity. It's all I'm looking for here.
What does
And
reciprocity mean?
Reciprocity. That's what I was talking about in the sandbox, that I let you speak until you're all done, and then you do the exact same for me until I'm all done. And you'll know when I'm
You guys
done
never
because
let
I'm
me finish,
saying
though.
something. What?
Yes, you guys rarely let me finish. I'm constantly getting spoken over. So yeah, I mean, I'm only giving what I get. But yeah, you're right. I'll give you reciprocity. Yeah, I need to practice. That's my new word for the day. Let me practice that.
Excellent. Reci, like recipe. It's like recipe, only it's prosody on the end. Okay, good. So what we're talking about here is assertions made by the mainstream regarding the sun, the nature of it, the material of it, the dynamics of it, the kinematics of it, and what we're talking about relative to the Newtonian assessment of it. Ralph, I also recommend that you buzz over to my BitChute channel and have a good long study of a certain series of videos that I have on my channel, and they all begin with a couple of thoughts about blank, whatever it is. There's at least half a dozen of those of just that kind. I recommend you check those out, along with the one about Felix Baumgartner. Like, get in there with your notepad and your pencil and the pause button and really take in the quantification of the analyses that I offer. I don't offer opinion in these videos. I offer the mainstream assertions and then put them up against other mainstream assertions and then involve mainstream formulae. And then I grab stuff off of nasa.gov in regard to the figures asserted by the mainstream. I plug them into the formulae and we see where we go. I thoroughly recommend that you get in there and do some digging and see what comes out, Ralph. I think that it actually will substantially change not only your awareness level of what you pretend to talk about, but your position on most of them.
Yeah, link the information and I'll take a look at it.
Okay, well, you're looking at Man of Stone, right? That's me. So just go over to BitChute and type Man of Stone, and there I am. There's
So you don't have a
there's
link?
not
You could
much
just
else
throw
to
in the
say.
purple pill for the benefit of the entire room, not just myself?
You could just right-click me, load up my timeline, and you could see all of the references you're looking for. They're right there too.
Yeah, it looks like it's all in his profile, man.
It
But
couldn't
going
be
back
easier,
to
Ralph.
okay, are you done?
You had mentioned that nothing had given you any convincing evidence of the shape of the Earth, Ralph. But what about Mount Canigou and this world record photography here?
Brian, we just spent like the better part of an hour going back and forth with that. You want to go at it again?
Well,
I'd rather not. But if you want to, I mean, fuck, it's your room. We do what you want.
I can give you new data on that subject. Again,
Well,
same
okay. Well,
BitChute.
so before you get into another
No,
very
on that
eloquent
subject,
line
on
of
the
words,
same
let me just
subject.
get my point off, Stone, if you don't mind. Thank you.
Again,
Okay,
go
so
ahead.
I'm not relying on the government to tell me the shape. I'm not listening to NASA to dictate the shape. I'm not listening to Democrats, Republicans. I'm not tuning into any national committee. No, none of that. The story, quote unquote, and I'll just use that word, that the Earth is round has been told by different cultures at different times throughout history. Some direct, some indirect. So I'm not reliant just on modern day Western Rothschild government to tell me the shape. No, there's other people, other cultures who have gone, who have passed, who are no longer here, who aren't relevant anymore, that had a spherical view to it. So that's just how simple it is. I could even get more
Okay.
tribal to it and say the Dogon tribe, who already knew about Sirius B, even though we couldn't even properly observe it at that time. And that's supposedly their creation, not their creation story, but part of their mythology, as that is
Okay.
that their gods came down and told them about
Okay.
Dogon, right?
Okay.
I let you speak,
So-
didn't interrupt, just
You
because
said a
you and
whole
Dean are
bunch,
dragging
Ralph.
with it.
You're going on. You're going on.
Ralph,
It's
We
cool,
don't need a
it's cool. Like I
scattergun,
said,
Ralph. One thing at a
let's
time.
just be mindful of what it is.
Ralph,
You
what
want
about the
respect, and I'm willing to give respect. I'm good with it though. So like I said,
what
let's just
about
kick it
the
over to somebody else.
So hold on a second.
what about the
So, Dan, hold on, Dan. So on this over here, on this world record photography there, you agreed that these mountains have to be a reflection. It can't be the real thing, right?
We went over it already, Brian. Just play the recording. I'm not gonna go through it again.
That's why I want to talk
we
about
we
new
gave
data.
each other a good hour to it, so I'm good with it already.
How about some new data? Okay,
You
Ralph.
you can provide that data to Nick, and then I'll listen in. But
Go-
I'm not
No,
gonna go
tell you
ahead.
what.
you're not ready for what I'm about to say
Well,
yet, Ralph.
That's
So
fine.
stop saying no
However you
before
want
I
to
say it.
quantify it to yourself, that's cool. That's your
Stop saying
mind.
no
That's your
before I say it,
Bro.
Ralph.
Go ahead, Stone.
Thank you. Thank you, Nick. Ralph, again, same BitChute channel. There's a two-parter, and they're like a year or two apart. And they are about a little story that Eric Dubé told years back, made a kid's story out of it about, getting your level, your little torpedo level, and getting on a plane, and then, figuring out how fast the nose is dipping and stuff. And basically the video is about how he's doing it wrong in part one, but part two is really the interesting part. Although I actually recommend watching part one first, just for context and background. Sets the stage for part two in a much better way. When you get to part two, you're going to see how I took advantage of commercial aviation hardware to plot the contour of the surface of the Earth. We're using light from a stationary position on the ground at an airport, hitting a commercial airliner with very precise gear. And I made use of a couple of commercial pilots who, sent me video of their instrumentation while they were performing very specific maneuver on approach to a runway. Take a look at these videos because they prove quantified proof exactly what the contour of the Earth entails. So we don't have to talk about opinion. We don't have to talk about mythology or any other previous civilization or what some dude wrote in a book who's not here to ask questions about it anymore. We're talking about first order measurement done with world-class, precise, light-based hardware. And it's the stuff, they got to have it exact because lives are on the line. So I recommend you go and check out both part 1 and part 2 of that Earth, the old assertion about Earth convex, that kind of stuff. It's
I'll put a link up.
delight. Yeah, thanks, Alan. It's a delight. I don't play around with opinion very often, Ralph. I only play with the facts. I only play with the quantified argument because there's no arguing about it. It just is what it is, man. And I suggest you take some time.
Well, you know what? I definitely need to take time to look at it because contour sounds like it's not flat. So yeah, I definitely need to look more into it because from what it sounds like you were describing topography.
Okay,
Like you were
I am
describing
describing
the actual shape to the Earth.
topography.
So,
Okay,
like
but
I
don't
said, I need
dismiss
to
it
look
out of
into it
hand
because it
until
sounds
you
like
watch
you're
it.
saying flat. I mean, it sounds
No.
like you're saying curve and not flat.
Hey, it doesn't matter what it sounds like. You got to look at the data. Okay, that's where you get hung up every time, Ralph. Go look at the data and forget what you think it sounds like before you see it.
Noted.
You're also forgetting that the Egyptians and the Greeks believed it was flat as well.
Well, we don't know that because we weren't there talking to them when they were believing it. Okay, all we know is what was in books and stuff. And I'm not interested in any of that when it comes to debate.
Well, what's crazy is that with this world record photography here, I mean, that has to match the globe model, and yet you basically agreed that it has to be 3 miles below the Earth curvature, and your response to it is, we're going to have to agree to disagree.
All that has to do with so many different variables to do with the observation and the setting and stuff that you can't verify just by looking at a picture, Nick. I want to agree with you, Nick. I want to say, hardcore, that's evidence. Well, frankly, as far as I'm concerned, it is, but it's not enough to convince them. We have to meet them at their level. And I think my MO is a little closer to hitting the nail on the head.
That's what I said, but that picture was not the best proof. I was trying to get you guys to pick something else.
Man, it's 275 miles away, bro.
Well, Stone, who's obviously
You
much
want,
more
man.
intelligent than me, kind of agrees with the same thing I was saying. That's not the best example to use.
Well, actually, no, Ralph, I wasn't conceding the point to you. I was just saying that it wasn't the greatest way to go.
That's literally what I said. That's not the greatest example you could use.
Did give him himself attaboy, and then you said no, and he was like, no, I knew what you meant.
I knew what you meant. Too much nut in there for me, Ralph.
Although I went to go get food, but Stone, that was awesome. That was an epic, slow, methodical, just epic. Thank you, sir.
Thanks, man.
All right, I put the videos up in the jumbo, so you can check those out. And then also I put in Marie Robitaille's video on the sun and spectroscopy, because as you were saying earlier, we got a lot to learn about the sun. Oh boy, do we, right? Homie breaks down the whole thing. It's all a fraud, right? So when they look up at the stars and then when they look up at the sun, they've never seen anything that emits a spectrum like that continuous spectrum. Like in the lab, nothing's ever done that before. So what they've done is they've introduced, quote unquote, laws and coefficients to mathematically conform the observation into what they would expect in the lab, given those gases. And then one of the core fundamental things that the whole thing is built upon, like for all this pressure to exist and for these elements to, be doing what they're doing, there has to be some, I forget what it's called, but it's some hydrogen oxide type thing. Anyway, that's never been observed in the spectrum in any thing regarding the sun, but it's fundamental and has to be there. And so one of the things he goes over is in mainstream astronomy, and they're, in the big journals for them, like it's part of their lore where they're like, we believe that this element has to be there, but we've never seen it. It's very elusive. It's like, yeah, they've got a ton to look over, and that really touches on like the overall takeaway from that, right? Isn't like, oh, we have a lot to learn about the sun. It's that these people have no idea about what the sun is or how it works, but they've established lore and literature around it, and they've all kind of agreed upon it. And now they're like pressing that worldview on you. And the real thing here is that you're free to think for yourself. Like, you don't even have to agree about what I think the sun is or how it functions or anything. They need consensus, right? They need you to agree, but you're free to do whatever you want when you look up at the sky and think about it, man, because they've never seen anything like it, and they just made it like what they expect to be in a lab.
Dude, that reminds me of meteors when they were like, we know for sure that ejecta causes 90 degrees laterally from meteorites from space, and all this happens. And it's like, well, no, we've never seen it. Like, all right, to be clear and frank, no one on Earth has ever seen this formation ever once in history or of science. But the next sentence is, we know that it's like, what do you know? You don't know shit.
What do you know? But no, it's
Ralph,
just, yeah, go ahead.
let's change the tone on the expectation a little bit, because I agree with what Shane just said. And for me, the thematic point to come away with on that is that it is going to be easier for us all as a group to agree on what it is not, and far easier than what it is. So let's just start with the first one, that it's not a big ball of freaking helium condensing in on itself into fission and fusion and yada, 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 yada. Just start there, and then we'll see where we get to.
Hey, real quick, all I'm saying is when you watch that, if you watch that video, pay attention to a specific argument he makes about gas pressure in a container when regarding the perfect disk of the sun we have. I almost mistook him for a flat earther. I was like, what would you say, Bree? What's that you saying? But anyway, just pay attention to that, because apparently, that's an important mechanic that's overlooked.
You guys know how Bennett like won't talk to people professionally unless they're not a retard or whatever. He put it like much more eloquently, but that's basically what it took away
You
from
require
it.
a statement of philosophy to establish the baseline.
Yes,
so
the philosophical prerequisite questions.
Yes. I think we should just put out base axioms now instead of like, these are the things I'm going to stand on, right? Nobody's measured Earth curve. Nobody's measured Earth motion. Nobody's ever demonstrated, gas being contained by gravity, and then definitely 100% necessary space is fake and gay. Outside of those axioms, like, I'm not sure, right?
Is this the one we put up here with the new real pilot data?
Yes.
So that one there, that's part 2. You got to get into my channel and go back a couple of years and go find part 1 first. I think it's probably in the comments or the description section of part 2 there. So it's easier to find.
I put them both in the same one and labeled them.
Oh, there it is, part 1. Yeah, there's the tag. Thank you, Alan. Very good. Very good.
I want to hear more about this base axioms thing.
I did just put a post by Ken in Jumbotron where he had highlighted those as his choice-based axioms, and I totally stole that from him. But Nickade, your white noise is intimidating. Speak or don't, bro.
Oh, is it the open mic or something? Can you?
Yeah, everyone's like trepidatious to like, are you gonna speak? Is he gonna? Is he about to? Is he just waiting? Did he forget? We're
in a real will he, won't he situation here.
No, I'm just rude like that and keep my mic open because
respect.
Sometimes I think I hit them, but I miss, and I go on to do other stuff.
And then we just like listen to you breathe heavily as you do other stuff with your thumb.
Are you listening to somebody looking for a lighter?
What is it, 9:30? Oh shit, it's almost 10 minutes late. Well then, where is Ken Slater? Hold on.
No, I got thinking about those those new ether pockets there, and started getting a little hungry there.
Yo, why don't we bring up Ruhif and then we'll all just like attack him? What do you guys think? I think he would like that, and I think we would like that. I think that would be a fun night.
Who?
You got Bruised Ferret down there. For some reason, his guys on Twitter is Bruised Ferret, but that is Ruhif, King of Globularity.
Yo, what up, Rue? Sorry about that. I thought I had my mic muted. You could hear any keyboard typing. My bad.
Go ahead, bring him on up. Is he in your timeline or something? Is he spamming you?
No, you didn't see us debate. We had
He's
the most
everywhere like a
vicious-
rash.
We had the most vicious debate ever. You should go watch.
You gave him a good intro, though. You complimented him.
See?
Well, he wanted to do relays so hard that I couldn't do it, but that didn't work. I just let him do it, He's the one wanted to get out in front of it, I think.
This Bruce Ferret, huh? All right, here you go. An invite has been sent, just for you, Shane.
Good. Now he's gonna come up, give himself his own award, be a dipshit, and be like, "Fuck Shane," and then peace out. Watch.
Jesus, the volume change between listener and speaker is intense,
isn't it? It changes codecs. We figured that out.
Yeah,
it's weird.
Makes a man out of you, though, doesn't it?
Oh yeah. You guys are talking about C2 without me. What's that about?
Yeah, and I told him to bring you up here, so.
Gee.
Get some 7/6R downward bending refraction or whatever.
Yeah, let's do that.
Now, is it true that there's local geographic coefficients you can introduce to also supplement if you're having like a bad day?
There are studies, particularly around like West Africa, where the normal refraction is way higher than the typical gradient. Yeah.
Do they have any gravitational anomalies over there too, or no?
I have no idea. Probably not.
Nice.
Yeah.
So anyway, you were saying that you can't see far enough.
I was saying the world record fits the globe basically perfectly.
Nice.
Yeah.
How is that?
Well, you guys deny refraction, right?
You're enabling him. Cut it out.
You're a refractionist, Nick Cage.
A refractionist? Are people up here denying refraction? Who's a refraction denier?
Personally, I love refraction, especially when it's refined with gravity to gravification or whatever.
I've been refracted my whole life. I just didn't know it. I'm in a refracted frame.
3 whole solid miles of refraction, and that's a shadow again.
Is it 3 miles of refraction?
Another refraction shadow.
I don't think it's 3 miles of refraction. What is it?
Are you in a
273 miles?
Are you in a wind tunnel writing a Python script how to prove flat Earth wrong?
Yes.
Oh, it's my settings up again.
It's the exact
change settings. 1 sec.
It's
Microphone.
205 miles.
Hang on a sec. How do I change the settings in?
Ooh, so you can't really do it in the Twitter app, if that's what you're asking.
No, in desktop.
Yeah, so you'd have to do it on whatever software you're using for your
browser settings.
The key is before you enter the spaces in Twitter, pull up any video and make sure that the volume is cranked on it while it's playing, and then just pause it and then enter the spaces, and the volume here will be maxed too.
I think it's using my actual microphone. Yeah.
You sound fine. And that's a good trick, Stone.
Yeah, you sound all right.
Anyway, what is it? 275 miles or something? What, 443 Ks. 443 Ks. Yeah,
Is that how gay the globe is? 440K or whatever?
And it was on top of Canigou or Fenestrelay? Fenestrelay on it. 2820. 9,252 feet. Does that sound about right?
9,000. I put it up there
Oh, do I have to look at the Jumbotron thing?
I can do it for you.
Dude, Ruhif typing is very intimidating. What Python script are you trying to write?
I've been doing GeoGebra this morning for Brian's Oh, funeral today for Sacred.
The elevation is 9,252 feet.
To be honest, Ruhif, when I go to TikTok and I see Brian Leakey's video and it always starts with you, I'm starting to get concerned.
Yeah, so 1.2 kilometers of refraction, which is less than a mile.
What?
What are we talking about? Sorry.
We're talking about Pic Gaspard, aren't we?
All of a sudden, he said 1.2 miles of refraction.
He was measuring
1.2 kilometers.
Or kilometers or whatever, but that distance in elevation, there's 3 miles of physical curvature.
Okay. What's the hidden amount?
There's 3 miles of physical curvature.
Okay. What's the hidden amount?
All that mountain would be beneath 3 miles of physical curvature.
Okay. What's the hidden amount? A number, please.
You can say that all you want. There's
and you can keep dodging it, or you can give me a fucking number.
What number are you looking for, buddy?
The hidden amount, the one I've asked for now 4 times.
What is the hidden amount that you're trying to get out of me? Because
the amount that should be hidden if the Earth's a globe.
That whole mountain should be hidden.
How much? What number? Is that difficult to give me a number? Really?
Wait. Didn't
I don't know the height of that mountain, if that's what you're asking.
It doesn't matter. What's the
I don't know the
predicted hidden amount?
I do not know the height of that mountain. So
I know the height of the mountain, 3,883 meters. What is the hidden amount according to you?
You tell me.
Okay, 3.8 kilometers. So it should not be hidden.
That whole mountain is hidden behind 3 miles of physical curvature.
What's the hidden amount? I'm not asking how much drop. I'm asking you the hidden.
Does anybody understand his reference?
It should be hidden, but it's not because there's no physical curve.
Okay, what's the hidden amount according to you? If you plug it into a curve calculator, what hidden value does it give you? It shouldn't be this hard, really.
Well, what difference does it make?
Must be new to the room.
Well, you say it should be hidden. I say it should not be hidden. So we have a difference of figures somewhere, right?
No, we don't.
Okay, what are your figures then?
Bullshit that no one even know what the hell you're talking about.
Okay, I plugged in a distance of 443 kilometers and a viewer height of 2,820 meters, and I get a hidden amount of 3.8 kilometers. The mountain is almost 3.9 kilometers, so you should see it.
Wait, are you saying that you have a way to predict how much refraction there will be to obscure the bottom up when I'm leaving observation?
I don't think you have the observer height right there. I heard it was just about around 1,000 feet.
No,
we're talking about.
No, Brian said 9,200 feet.
Yes. Would you like me to do Imperial? I'll do Imperial just for you guys.
Yeah, you might. Make sure it's not 2,800 meters or whatever.
I actually only take measurements in baby terrestrial.
Record. I told you, Brian, we should have picked something else than Mount Canigou and that world record picture.
Well, we can do Canigou if you want, but we're
you want to come up with some obscure bullshit of what's hidden.
Well, if you can see something, it's not hidden. If you can't see it, it is.
Exactly.
Is that a good enough explanation for why the hidden amount's important?
So
right.
it's not
Should
hidden.
I be able to?
Right. The mountain is there, so there is no curvature. Thank you very much.
Okay. Should I be able to see it on a globe?
No, you shouldn't.
No. Okay. What figures are you getting? How do you make your prediction that it should not be seen on a globe?
Whoa. Okay, I think Ken should ask Ruhif his very eloquent, well-put proposition from earlier where he proposed where you would know how much refraction there'll be ahead of time before we make an observation. Ken, go ahead.
Yep.
Ken might be busy. I don't know.
Are you talking about the predictive value?
Yep.
Yeah.
The terrestrial refraction.
Right. Well, let me see how best.
Mute up, Libra.
Also, stop watching the news, Libra. It'll rot your brain.
That's the radio. Sorry.
All right. Is Ken going to ask me a question? Is Ken going to ask me a question that Shane already knows the answer to?
No, it's just with whenever we have long distance sightings, right? You always have the information ahead of time, observer height, distance to the object, right?
Yes.
So you come up with a refractive index that gives you what that refractive index would be to see that far on a sphere.
No.
Yeah,
No.
there is no equation that you can give me that I can go and check the data for before I leave my house with a camera, and I can use that equation to predict how far I'm going to see, because in order to establish that that is there, right,
All right,
it should
Shane.
have some predictive value, but it doesn't have predictive value. All computations are made after you have all the information.
All right, Shane, can you steel man the globe response?
7/6R doesn't cut it here, man.
Okay, I'll give the response. All right. Every day, twice a day, thousands of locations around the world, they send up weather balloons, right?
Oh my fucking.
This is the response.
Here we go.
Here we go. Every day.
I thought you guys like weather
thousands of-
balloons.
Second.
He was giving you a cheer from the sidelines. Go ahead,
Right,
continue.
okay. Anyway, so they send up weather balloons every day, thousands of locations, twice a day. On the way up, right? So they're helium balloons. On the way up, they measure the temperature, pressure, humidity, all these other variables, right? And that data is available. You can get that data. And with that data, you can work out the refractive index of each sample at each elevation, right? And what I've analyzed all this data, and what I found is that once you are above, say, 100 meters above the surface, then refraction is predictable and stable. So yes, I can predict the refraction.
So then we should test that, right? We should make an observation from a certain thing without giving you the data, and you should be able to tell us.
Yeah.
Okay.
Absolutely.
Well, let's do that. Let's put 7/6R to the test then.
Yep. Yeah, like I've been asking you guys for years to get on top of a mountain and make a theodolite measurement, vertical angle measurement to another mountain.
Cough.
Yeah, well, I get the answer right there, don't I, Stone?
This is how McToon made himself irrelevant. This is why McToon is irrelevant. He's messed up during the debate because the guy didn't call him on something, but he still lost because they basically every distance outside what the globe cult is comfortable with is refraction, which is ridiculous, of course. So that's going to be the new thing for a while.
No, can I? Well, hang on. Can Shane Steelman the response to that?
I don't appreciate you making me seem like a glober, okay?
Okay. Below, right, if you are super close to the surface, yes, we can make any refraction excuse we like. Deal with that. Right?
All right, I definitely could have said, listen, I'll invoke refraction of a sphere of infinite radius if you make me, so don't fuck
Yes.
with me. Is that not the glober answer?
Right? When you are close to the surface, the refractive gradient can be extreme in either direction. So unless you make some good measurements of the refractive gradient close to the surface, you're allowing us making the refraction excuse, right? Like I said 5 minutes ago, once you get above 100 meters, refraction is predictable and stable. So your best plan of action is to hold us to 7/6R when you're above the surface by a decent amount.
Yeah, counterpoint, we could just take the observation, make it optical, back it up by angular resolution limit, and then just take all optical derivatives for anything inches per mile squared, disappearing would be ours, right? But that's what I would do.
That is what you would do, Shane. Yes. I won't ask Shane I won't put him on the spot anymore today.
Just not for Glober stuff. Ask me flat earth stuff. People are going to get like a complex or whatever.
You have the burden of proof. The globe has the burden of proof, though. But it has to be void of logically fallacious reasoning, lies, and projection.
Okay, so you don't make a claim to the shape.
We don't have to hold you to anything. Basically, we have standards. We have proof. That's done.
Oh, you have proof. What is that proof?
all the stuff all these people in the chat and those they just pretend they haven't seen, and then give us crap for proof.
Okay. So getting back to Pic Gaspard, all right, should it be visible on a globe? Anyone? I've heard
I'm gonna
plenty of
say
people
yes.
say it should be hidden. Who said yes? Was that Ralph? Yeah, nice one.
Yeah, no,
You're glad,
obviously,
Ralph.
I'm gonna say yes.
Yes.
Ralph's just that cheerleader, I guess, right now for you. So we'll just.
Yeah. But
Just
is
doing
anyone
what you
going to
guys
say?
do, supporting the community, right?
Are there any flat earthers going to say that it should not be visible on a globe? And if they say that, show your work.
Everything outside of 5 miles should be obstructed by curvature, right? According to your circumference.
So if the Burj Khalifa is 5 miles away, should you see it?
Hey, how does the Gaussian like regular coefficient 0.13 affect something when it scales up to like 2? Right?
What do you mean when it scales up to 2?
If like, isn't that like an extreme situation? Would it ever go that high, right? Because I heard McToon say, "Oof, boy, I don't know, Black Swan could be like a coefficient of 2," and I've been like, "That's
no 1." Yeah.
Okay, but 2 is pretty high. But the average 0.13. Right?
I think most surveys use 0.14. I think.
Good.
What's his name? The Larry Scott guy. Larry Scott, I think, is 0.15.
So does 7/6R comport with the average of 0.13?
It's closer to 0.14.
So then how does an average 7/6R refraction rate account for anything when we get like, super too far distance observations? How would that not, like, that would be out of average, right?
Right, but do you have a super too far observation that's not close to the surface?
Because you'll just invoke math of sphere of infinite radius with a straight face. My God.
Get away from the surface.
My God, how do you do that?
I've only been saying it for 7 years. Get away from the surface.
It's so far from the regular, like you'll just unblinkingly invoke refraction 20 times than the average for any circumstance without blinking an eye and go to the.
Yeah,
that's going to be the new thing, I'm telling you.
Did you post the FE Core thing on Twitter yesterday?
What would you get, an alert, buddy? Did you have that set up on Google Alerts?
I did a presentation on your channel on the.
I know.
Wrote a script.
I know. I didn't quote that. I quoted the other stuff. I left you out specifically.
They measured the gradient, and the gradient was way stronger than the curvature of the Earth.
What?
They measured that one of those measurements, number 5 at where was it? Enkhuizen to somewhere else, over the lake, whatever. They actually did make a measurement of the gradient. They took a measurement at sea level and took a measurement at 2 meters above sea level. That gradient in those 2 meters was extreme. You would see flat.
So, I mean, I posted FE Core laser tests, and you were like, someone probably sent a text, there was a phone call, someone sent an email that got an alert, and then someone on Discord sent you a message, and you were like, aha, someone's doing it again, and then you were here.
Yes. Or I was just looking at Twitter, and I follow you.
Now what I said makes more sense.
Exactly. Anyways, is any flat earther willing to say Pic Gaspard should not be seen if Earth is a globe?
Wait, how far above sea level or above level are you saying you want an observation?
At the very minimum 30 meters, but ideally above 100 meters.
And why is that?
Because the data says that once you get above 100 meters, refraction is quite predictable and stable.
Because no matter how far you see at the surface, he'll just math his way out of it. That's what he just said, though.
Or
so whatever you see, we'll just apply some refractive index to it.
Or what?
This is why you see it on a flat level plane and not on the other side of the physical curvature and coming up sideways. And if it was refraction, so everything you see is basically a mirage until you get to it and it doesn't move, and boom, there it is.
All right, give me an observation. Let's go. We were doing Pic Gaspard, but no one seems keen to defend it.
We could do Mount Canigou.
Sure, Canigou's great as well.
Go ahead, do Mount Canigou.
All right, let's do it from what's the one I've got already?
How you refract a silhouette?
I'm actually making a video about that.
1,132 feet is your hidden curvature there.
Let's get the exclusive from Ruhif, the glob, which will soon be the globular position. Ready? The refracted silhouette. Here we go.
Yeah, it blocks a curved path of light. Big whoop.
You got 1,132 feet of from the top of that mountain to the top of that curvature.
Okay, so you're claiming that it should not be seen. Is that right?
How does refraction refract the absence of light?
Okay, I probably need to draw this.
How do you demonstrate that?
Right, you block something, right? Let's assume the mountain's not even there, right? And you've got sun coming, light coming from the sun.
Also, we're going to start with assumptions, huh? Okay.
Okay, it's a thought experiment, jackass, right? Let's say the mountain's not there. Hey?
Jackass.
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 I can say it too, man.
Yes, okay.
So we're going to go ahead and assume. So we're all going to.
It's a thought experiment, jackass. Okay. Do you want to do the thought experiment, or do you just want to be a dickhead?
So you're gonna say it's a thought experiment now. Okay, go ahead.
It's a thought experiment, right? Let's pretend. Let's pretend, because we have imaginations, right? That the mountain's not actually there.
I got it. I've got to pretend.
Okay. Cool. All right. So the light is curving, right, through the atmosphere. That's what an atmosphere does, because it's got a density gradient. Are you with me now? Yes. So the light's
Keep going, bud.
Okay, the light's curving.
Pat on the head or something there. Keep going. We're listening.
Just checking you've got the intellectual capacity to keep up. That's all.
We can hear every stupid word you're saying, man. Keep going.
An attaboy and a dickhead tone. That was crazy.
You've got me today. I was going to say, yeah. So the light's curving.
Refraction. It's all refraction. That's what you're about to say, right? Is that the gist of the story?
Well, light curving is refraction. All right. So now, does it matter where in that path I stick the mountain to block the light?
Yeah, it's behind 1,132 feet of curvature.
Well, you're ignoring refraction, so I'll ask again. Does it matter where on that path
you're ignoring
I stick the mountain?
32 feet. You tell me how done. Show me an example, man. Give me an experiment.
I can't draw. This is why Twitter is shit, because I'd bring up paint and draw it.
Go ahead and provide an experiment and do it. You want to explain it. I want to see it. Go ahead.
The path of light is curving.
Tucker, where are you from? Huh? Are you upside down right now?
Yes. Upside down. The path of light is curving from where the light enters the atmosphere till it reaches the observer.
Prove it.
We have a density gradient. Light bends in a density gradient.
Go ahead and prove it, bro.
Do you deny that light bends in a density gradient?
Do you deny? Prove it.
Okay, whatever.
That
anyway,
sounds
the
like
light is curving. Yeah, the light is curving through our atmosphere.
You're telling me that you can refract a shadow, and I'm saying
I'm explaining to you, and you keep interrupting as if you don't really want to know the answer. That's the feeling that I have now, is that you don't really want to know the answer.
I don't want to hear your explanation.
That's projection.
Okay, there you go. You don't want to hear my explanation. At least you're being honest. At least you're being honest. You don't want to hear it.
I want to see your explanation. I want you to prove it. You can explain anything you want, but you can't prove it. And that's all I want to see, man. If you can provide something, I mean, you might convince me, man. You might make a globey out of me again, man. Refract a shadow. Refract a silhouette. You got 1,132 feet of curvature, hidden curvature there. Refract a shadow, buddy.
Okay, Rue, you were complaining about not being able to use paint, but when we really truly choose to embrace technology, nothing is stopping you from simply doing what you want to do in paint, saving the file to your desktop, and then posting it on your own timeline as a tweet that we could all see.
Yeah, or we could just go to Discord. That's the other option. But yeah, Nicolas Cage said he doesn't want to hear the explanation, so that's what I thought.
Stop acting like a child.
No, I did not say that. I said I wish you to show me. You talking about it doesn't impress me. I want to see it because it sounds like it's pretty simple. So do it.
Although to be fair, Ralph is super impressed. He keeps emojing the hell out of you, and he's got 2 pom-poms. So
Nice. Anyway, if I get muted again, I'm going to go. The explanation is, well, the question that I've asked you now twice.
Yo, Cass, what's up? Are you there? Your mic lit up, but no audio came out. Like it was really garbled.
Flat Earth map, which is a flat Earth model, which is just a drawing.
No, Ralph, I wasn't talking to you. Quiet, real
Same
quick.
level of fucking quality.
Yeah, ease up there, Ralph. We're talking to old dude over here. Whatever ferret face over here.
I ain't asking him a question. Why did I ask him a question? See if he props it down. This guy couldn't catch me. It's almost like they're fighting.
Hey, yo, Cass, you there? Yo, Cass, are you there?
Are they favored for this?
Oh, no,
Yes. I don't know.
let's see.
I don't know if you haven't. I don't know.
Replication of this.
How would
and
you
it would just
propose
right back to
to
square
model
one.
the refraction,
me, bro.
Given that I can't change the density of the air?
What's a silhouette? What's the definition of it?
Yeah, so light's being blocked by something.
And what's blocking the light has to physically be there to block it.
Right.
And how does refraction refract the absence of light?
Yeah, refraction
It
doesn't
can't
refract
happen.
the absence of light.
And that's what a silhouette is.
Right.
So you cannot replicate that. So what we are observing 162 miles away, 162 plus miles away, is the actual mountain.
Do I have to do it in paint and like send it to fucking Alan or Shane? Right?
It will be tilted away too.
If you want to join
sure.
Discord and start a stream, I can bring it up for those that are watching at home.
It's pretty simple, right? Let's say the light from the sun is curving. Does it matter where along that path I stick an obstruction to block the light? No, it doesn't. The light doesn't reach you. You've got a silhouette, regardless of whether it's.
You have to have the
you know,
physical object there.
Yes, no one's claiming that the object is not there. It's a mountain. It doesn't fucking go away.
Yes, but it's supposed to be hidden behind 10,000 feet of curvature. That means refraction is bringing that mountain up and then also bringing up its silhouette. It doesn't work.
Oh my God. Hang on. I'm going to draw it. I'll go on mute for 5 minutes. I'll draw it.
I don't think you can draw it.
Houston, we have arrived.
Yeah, I got it up there in the Jumbotron if you want to actually see the picture and the numbers of what you're trying to deal with there, man.
Do I go left or right on the Jumbotron?
It's going to be, of course.
Yo, is that our boy Witsit down there? Do you know a thing or two about refraction?
Oh, Witsit, yeah. I'm responding to Witsit. The video is responding to Witsit tomorrow.
That's shocking. That's number 73 on your channel directly about Witsit or whatever.
I did 3 on him a couple of months ago after the debate. So to go left for the most recent one.
Jake, you know how many videos I have on my channel about Witsit? And I like the dude.
0.
Ooh.
It's 0. It's 0.
Yeah. Do I go right to find the most recent one?
Yeah, I guess swipe
No, it's to the left.
to the left and go to the right. I don't know. I'm not down with the lingo nowadays.
You don't think that's little fake and gay, Ruhif? How many like videos dedicated to other men are on your channel?
I think most of them are to men, are they?
I mean, what?
Oh, hang on, no. What is Shungite? Does it have healing properties? Is that the first one?
Is that a fake and gay dog?
I'm trying to find. Someone said they posted the Kanagu numbers.
Yeah, it's a sacred post.
No, actually, it's not. It's mine. It's right after the world record one. Sacred did post.
Well, it's here.
Yeah, Sacred
should
did do about it, but
he's technically not here. That's an ethereal ghost until he gets a speaker role.
All right. But he should watch my videos.
No, I gave him an invite. See if it comes up when he's available.
I personally guarantee you he will never watch one of your videos. Without even talking to him, I'm going to make a prediction.
He's feeding Aaliyah. Or taking care of her right now.
Aaliyah?
Yeah, he's just chilling.
I thought I heard Aurora, wasn't it?
I just work here, brother. I don't know.
Don't question me. The name is what I said it was.
Right. I mean, he could be taking care of either one of them, dog. I don't know.
I can't see anyone that's posted the Kanagu numbers.
It's Sacred's post. It's around the 7th one.
1, 2, 3.
It's titled Kanagu Mountains, March 2nd. 9,000-foot mountains, 160 plus miles away, 1,000-foot elevation from the observer.
Oh, you guys mean the flat signal?
well, I also I
Talking about
posted
Flat Man?
I posted it up there in the jumbo with just the. I don't know if it wasn't a sacred one. It was just mine.
The video is 2 minutes and 18 seconds.
There we go. Should we observe 9,000-foot mountains 106 miles away? Yes.
No.
Yes. You just ignore refraction.
No, you just think refraction is magic.
No.
Yeah.
I think refraction is scientific. Do you deny like
So refraction will bring up an object up above an incline and make it appear as though it's on a level surface? That's crazy. And it happens every single time.
Does
Right.
That's pretty magical.
Hang on. There's been 5 questions asked, one at a time.
Does it make anything bigger, bring anything closer, do anything other than raise it up and put it?
No, it moves the location of the horizon.
So the only thing it does is bring it up and put it flat and level, as though it were on a flat level.
Do you think that looks flat and level?
Yes.
How much do you think we're seeing of that mountain?
More than what should be expected on a globe, which is none of it at all.
None of it at all.
But how much do you think you're seeing in feet?
But how much of it do you think you're seeing? Because you should.
This one is about
a mirage, dude. That's an image.
That's probably 1,500 feet visible. That one.
That's an image, man. That's not even the mountain. That's a. That's
I understand. Yeah, it's a silhouette.
That's a mirage.
Refraction removes a tilt that should be
no, it's not
away on a curve. So it's also a tilt removing tool.
A silhouette.
Refraction does not remove tilt.
Are you saying it's a silhouette?
Yes.
That would actually be a solid object with the light behind it.
Yeah, solid objects block light and cause a silhouette. How hard is that?
You need it to be is a mirage that got pushed up.
No, not a mirage.
Yes.
Mirages are distortions.
Because your mountain is way down there on your ball.
Geometrically, yes. But we have an atmosphere.
Because that's
You just said mirage is distortion, and refraction is what causes distortions.
Yeah,
We're not seeing more of something in the distance due to refraction.
At 8 inches per mile squared. Hold on a minute. At 8 inches per mile squared at sea level, that mountain that's 9,000 feet is actually down below 18,000 feet of curvature.
Okay. Is the observer at sea level?
I'm telling you what the actual curvature rate is at sea level. I didn't say the observer was at sea level. Do you have?
But I'm asking you, is the observer at sea level?
This is not a thought experiment, man. Follow along with the conversation, bro. I said at sea level.
Okay.
The curvature is 18,000 feet. Those mountains are 9,000 feet.
Let me take him through the rough math to satisfy him. Okay, so if you're looking at 1,000-foot observation, you know you want the root of that, right, Rue? Which is 31.6, and then you want to multiply that by 1.22, blobby blobby, don't care what it is, right? That takes you about 38.5 miles towards the target, where you're supposed to hit the horizon threshold, right?
Sure, sounds about right.
So let's say that leaves you 125 miles left. It's more, but let's just say 125. Okay, we're going to square that. We're going to divide it by 1.5. We're going to get 10,400 feet.
Okay, you ignoring refraction again?
Could we just get this far?
Nope.
That should be hidden if we didn't have an atmosphere, of course.
I'm just talking about the raw geometry of the curvature. Are you with me, Rue?
Yes. If we did not have an atmosphere, if we did not have an atmosphere,
10,400 feet. You got that figure?
if we did not have an atmosphere, yes, we
Now,
should not see
Rue,
it. But we do have an
what is
atmosphere.
the peak elevation of that mountain set there?
9,000 and something.
Right. So I'd say we're looking at least half of it.
Oh,
right?
okay. That's a
At
claim.
least half, maybe 5,000 feet of that stuff, right?
Okay.
Where we're already saying that the peak, before you want to talk about bendy light, the peak should be 1,400 feet below that threshold we found in the first 38 miles.
So the claim is we're seeing 5,000 feet of the mountain?
Rue, what did I just say?
Yeah, you gave a straw man of the globe, which has no atmosphere. But then
I
you
was
said,
talking about the raw geometry of the calculation. What did I just say?
yeah, if we had no atmosphere, you shouldn't see it by about 1,000 feet.
We're not
Agreed.
1,400. The
bro.
peak by 1,400 feet, right?
160 something.
Now we're talking about the extra 5,000 that I'm saying at least we're already looking at here. The point is that we're really looking at the whole mountain. It's just that none of it is lit up because of the limitations of the CMOS inside the camera and the programming that it is afflicted with.
So you're denying the horizon there, right?
That the range of contrast that this camera is capable of actually picking up is nowhere near that of the human eye to begin with. Let's just admit that right off the top. Second, it's probably compressed a fair bit. Not that that matters, but really, when we add the $5,000 to the 1,400, you can't make all that magically go away with bendy light at 1,000 feet. I'm sorry, Rue, but you just can't. Quantifiably, you're kind of fucked on this one, man.
All right, so you're denying that really dark area in the
It's
photo.
not about what I'm denying, Rue. Don't put it into
is.
me.
I'm asking you a question, Stone, and I got halfway through it, and you just interrupted.
On, and I'm
so I'll keep talking until you say
fucking flat Earth crime.
Keep going,
here or
Stone. Keep going.
something.
Keep going. I can make audio chaos until I get muted again, right?
You
Now,
can just keep interrupting all you like.
I was the one that got interrupted. So are you claiming that the dark part of that image is not the water?
Easily.
Okay, then yeah. Like I made a video about you a few months ago, Stone. You're just full of shit. You're a liar.
I'm a liar. Yeah, I got my big black cape on. I'm just a perpetrator of flat Earth crimes.
How many videos?
That's me.
All the men thought I said you said 0, so that's 2 of Stone, 4 to 60
One
of
for
Wits
Stone.
it. Okay, but
yeah, if you deny that's the ocean, I got nothing else to say to you.
I just explained, although you tried to interrupt me 3 times as I did, the limitations of the camera that took this shot.
Yeah, I'll just repeat myself. If you deny it's the ocean, I've got nothing to say to you.
We deny the globe, brother.
Right back at you. You're denying the limitations of the hardware used.
All right. We'll have
That
to
makes
agree to
you
disagree.
the liar.
Okay. I think everyone here knows it's the ocean, so whatever.
Dude, what kind of observation would require refraction coefficient of 1.8, do you think?
1.8.
Yeah, like what kind of conditions would be extreme enough to warrant such a ridiculous coefficient of refraction, 18 times bigger than normal?
Maybe over the ice. Like
Really?
right next to the ice, yeah.
Really? So you can already think of a plausible condition where a coefficient 18 times bigger than what is normal would be called for.
Yeah, the where was it? Yeah, the FE core was about 900. The FE core one was huge.
Yeah. How much refraction did you have to add back in to negate what FE core did?
No, I just showed that the refractive gradient that they measured was easily bigger than the curvature of the Earth. So you would see it as flat.
I thought you said they didn't account for refraction correctly. That was your main contention back when you did the thing.
They didn't account for it correctly, but when they did actually measure the gradient, it turned out that it was an enormously steep gradient.
Like, would you say the gradient always matches that supposed Earth curve or whatever?
No.
You don't think so? You don't think that, like, when they're defining, say, like an arc of light, that it actually says that light curves at the radius of the Earth anyway?
No.
Did you know that?
Typically, it doesn't. 706R is nowhere near the curvature of the Earth. It's like a seventh of it.
Yeah, but like the definition of a light. Hold on, I'll show you. Right up there with refraction being defined, as like the radius of the Earth, with like curving of the radius of the Earth.
Relative to the curvature of the Earth?
I have something for you to consider, Rue.
I've got no interest, Stone. If you can't acknowledge that that's water, like what's the point of having a discussion?
Okay, you can be a dick or you can listen.
Right. You don't think they take video before the sun sets?
What is it going to be?
He has chosen being a dick.
Dick it is.
You don't think they take video before the sun sets and you can see the water?
Sorry, buddy. I don't talk to dicks.
Okay. We understand each other, Stone. We understand each other.
Yeah, you're a dick.
We're having a real Mexican dick off here.
I'm happy. I'm happy for liars to call me a dick. That's fine.
Yeah, you with your magical refraction that puts everything right there where we'd see it on a flat, stationary, level plane.
Yeah, I can't help if you don't understand it and think it's magic. That's not my issue.
Well, it does seem to appear like it's not beyond a curve.
All right.
Always bringing up magic.
Let's see. What do we got here? Did I put in the Jumbotron?
Like the cavemen used to think thunder was magic, right? Because they didn't understand it.
So we have, let's see, the start. Right? It says that refraction K, or the regular coefficient, is big R over little r, right? And the definition is based on a circular arc used to model the irregular curved path of light. And it says based on a mean Earth radius of 6,370 kilometers. It says, i.e., follows the Earth's curvature, right, in the coefficient of refraction definition. So that's always what it's going to do, right? That's what it's designed to do. And then it goes into the next page. It says the radius of a circular arc as a mathematical model to approximate the curved path of light based on geodesy and the curvature of Earth. So
when
that's
it
where
says follows Earth curvature,
yeah,
that just means in the same direction, not at the same rate. So it follows the convex.
It follows it as a ratio compared to the little distance and then the big distance. That's what it does, right?
So big R, big R 6371 on top and something like 45,000 on the bottom gives you the K. What is that? 6371.
Yeah, right. Which is plugging in the radius of Earth, right? So in the actual coefficient, you're like invoking the radius to say that the arc of the light is already curving, just so happens at the same rate and in the direction of the Earth.
Not at the same rate.
Curve, yeah.
Not at the same rate.
The rate gets made up by the additive coefficient later when you backwards engineer how much height there should have been from observer height, right? So that part gets
incorrect.
Come on, at least admit it.
No, the ratio, the radius of the curvature of light comes from measurements of the gradient. Nothing to do with the curvature of the Earth.
But it's got a mean Earth radius in the definition and calculation.
Let's take refraction out of the curve calculator.
Well, hold on. How does that not have to do with what you just said, though?
No, let's take refraction out of the curve calculator. Do you have an issue with it presupposing the radius of the Earth to make a geometric prediction?
to make a prediction.
Yeah, that's what we're doing.
This isn't a prediction. This isn't a gradient, and this is the defined average that everybody uses all the time, no matter what altitude and/or conditions.
Right.
Right. Okay.
But the question, you seem to have a problem with presupposing a radius to make a prediction. Do you have that problem with the curve calculator if it doesn't have refraction in it?
No, you can use the proponents of your geometric sphere to make predictions, but you can't claim that those are therefore the norm, and then outside of that is now not matching the definition or is irregular, right?
They are the norm. A light radius of 45,000 kilometers is the norm, and we just incorporate that into the curve calculator. That's what 7/6R is.
But yeah, I forgot why I don't ever argue this shit with you. I remember now. Just then.
Valid. All right. Is Witsit going to come up?
I bet you once you leave, he might. Yeah.
All right. Let him know. What's one thing?
Witsit?
What can I say? Yeah, tell him his drone measurement of the horizon is rubbish, and you need a.
Ruhiv says you suck. Yada yada. He'll get you later. Meet him at the playground. All good.
Yes, meet me outside the toilets, behind the toilets.
Meet at Chuck E. Cheese.
Has a life.
Who knows what the E stands for?
He's got a counter for everything, man. It's refraction.
Dude, I heard he's actually fighting Globers now. So if you want to get in line, that may be a spectacle or whatever.
Oh yeah, how cool is that? He's gonna go fight that guy.
And he's got a beard better than Chuck Norris, so.
Oh, stone, 5,000 feet visible, hey? If only there was some massive yellow-white object in the frame that has a known angular size.
Who measured it?
The sun. You don't think we can measure the angular size of the sun? I've measured it. Would you like to see my measurements?
How much guessing did you do in that?
Kind of. Is it in spreadsheet form?
No, it's a P900 photo. You get the focal length and you just measure the size of the sun in pixels.
Still kind of. You gonna pixel count for me?
Yes.
Pixel count it up, bro.
Yeah. Anyway, the sun is half a degree wide, right? You know how much of that mountain is visible in angular terms then, right? You also know how far away it is.
Oh, you're grasping, bud.
Dude, you
What's
count
your name again? Ruiz?
Let's do it.
You count the pixels in the sun, and you count how many suns it takes to make up the visible mountain, and you times that by pixels, and you're like, ta-da!
That's exactly how you do it.
My God.
Yes, that is exactly how you do it. The sun is.
You got to picture 1,000,000 Earths in the sun, and then.
Oh, bro! I had a guy tell me he was counting the pixels on the Discover images, and we counted the ones at the equator. And that's how he knew that, it's a pair, like Neil deGrasse Tyson said. But aside from that, though, Bruce Ferret, there was a question from the YouTube chat that came in for you. My boy Ion wanted to know if there was anything that could be presented to you that would give you serious question, that would give you, reason to question the globe. Like what evidence could be presented to you that would make you...
Yeah, measurements that are not consistent with drop.
Well, there you have it, Ion. Nothing.
Yeah, I agree. There are no measurements that aren't consistent with drop. So,
I think what he said was, as long as I can math my way back to a sphere, there's no chance.
So how much? So we look at the width of the sun.
Math consistent with a drop?
Say again?
Did you say there's no math consistent with a drop?
No, there's no observations that are inconsistent with there being 8 inches per mile squared of drop.
Of course there is. You just invoke refraction.
Right. We have an atmosphere. It bends light.
Oh, okay.
Correct. But you invoke it, and then that does the same effect everywhere. It makes everything appear as though it's on a level surface.
Should I ignore something that is always there?
So
would that be a good prediction?
On a 360-degree turn, if you turn your head, you get the same refraction everywhere.
Say again?
What happens if you turn around and get you get the same refraction all the way around you?
Yeah, if you're well above the surface, yes.
Hey, man, is it possible? Can we ask Stone here a question, my man?
Yeah, go ahead.
Well, I mean, I'm sitting here listening to this, and it's quite comical, the intellectual dishonesty here, Stone. So do me a favor. How are you going to reconcile this one, my man? Since we know bodies of water lay flat and the luminaries above our head have absolutely nothing to do with the foundation upon which we stand, I want you to tell me how in the world this refraction, are we living on refraction? Is that what's popping in your mind? Are we on light benditures and just different type of word salad and nonsense? Is that the deal? Are we on light now?
You started that with a question for Stone, but I got the feeling that was for
I
me.
got a feeling that question
I
is
was-
not
I
for
was
me at
confused.
all.
Yeah, I think that was for bruised ferret face or something over here.
Yeah, whoever the Globey is, my bad if I
Yes.
called you out, buddy. My bad.
Yeah, you gotta pay
Okay.
attention, Brian.
Ouch.
We have an
Good
atmosphere.
try. Good try.
I think Stone could answer it though. I'm pretty sure.
Yeah. Oh, yeah. Go Stone.
But
No, you go ahead and Brian, shoot it at the old ferret there, and let's see what he says.
Who is it? My bad.
Shoot it
Stone.
at his stupid face.
Who's
Get his
the
stupid
one
face.
that's in the Globey?
yeah, it's the ferret face there.
Okay. My
Yeah,
bad.
so
My bad.
we have an atmosphere, right? We have an atmosphere, and the typical structure of that atmosphere is that it's more dense at the bottom and less dense higher up. That causes light to bend. That's what refraction is.
And that's what we live on is refraction.
That's a I can't say the R word now because my daughter's in the room. That's a very silly statement.
Didn't hit us hard.
Say refraction? Yeah, that is a bad word. Don't say refraction anymore.
Alan, count pixels of the width.
Oh, I didn't want to interrupt. You can just answer.
Please don't do that.
Yeah,
you count
That's
the
way
width
worse.
because it compresses vertically.
No, I got you. So
due to refraction.
So you're saying you wouldn't be able to tell anything from that, like discernibly?
They can. You just do it by the width. You don't do it by the height because it compresses due to.
No. This is
refraction.
completely separate from what you're. This is. Are you, do you?
The point is that Rue wants to use a visually distorted object as his metric.
The width is not distorted.
They are both distorted.
No.
Christ.
Yeah, well, separate from this situation though. Is it a blade or is it a sphere, like perfect sphere? Is it discernible or no?
Is the sun itself a perfect sphere? Is that like in?
Yeah. I'm asking, like, when you pixel count, like, what do you get? Is it a blade or a perfect sphere?
Or is it pear shaped?
That's a good question. I think I just counted the width. I should count the height of it, eh?
Do you get more pixels at the
Yeah,
bottom?
let me know if it's a blade or not.
Yeah.
It's for
Well,
astronomical
it is oblate.
purposes, but anyway, you guys can continue on. This was just a separate.
It is
side
oblate
thing
because
for me.
it's rotating.
To
That's why I sent.
chat.
That's why I sent you a DM so that this wouldn't happen.
Okay,
Like,
sorry.
but cool, man.
I
If
raised
any-
my hand for this particular subject, man. I just wanted to say a quick word. I'll just really enjoy listening. But Rue, if I just made a video on the taboo conspiracy where you tried to debunk it, and I used the sun. I was wondering why you didn't use the sun, because you always use the sun when given a chance. And I ran the numbers, and the sun was over twice the size of that ship you were saying is 16 miles away. And if the ship was 16 miles away, its angular size would have had to have been the exact same size as the sun. And it was over half as small, refracted or not. It's still the sun right there. So what says you, man?
All right. Number one, you're aware that the person that took the footage now acknowledges that it is the ship that I said it was, right?
It can't be.
Well, he acknowledges it, and Taboo.
Yeah,
took the
he
video
acknowledges
down.
because he hasn't seen my video yet.
Okay.
Once he sees my video, Taboo took his video down. As soon as I get a hold of him, he's going to put it back up because it can't possibly be that ship you're saying.
Okay. Please show me the frame in the video where you measured the width of the sun. DM it to me in Discord.
To be fair, if anyone's wondering about questions from Ruhif, right, there is nothing on Earth. There is no observation. There's nothing you can bring him that will bring him over to our side. Matter of fact, he said if there was anything, he would first commit himself to a mental hospital, direct quote.
Correct.
Yeah.
Did he request measurements of the sun? Who measured the sun at 93 million miles away?
Oh,
Well,
it's
that's
been
funny.
triangulated.
Well, it wasn't close enough to have to measure it. I mean, it's this simple. It's 16 miles away at 239 meters long. The thing would have had to have been 0.51 degrees, which is almost the same exact size of the sun. Okay, at 34 miles, it would have had to have been 0.25 degrees in angular size. And so it wasn't even close. It's a little less than half the size of the sun. It's not like one I had to count pixels. It's freaking obvious. It's not even worth counting.
Right. Is the sun more than half set in that footage? Yes. Also, is the sun very, very distorted in that footage? Yes. You can't get an angular width of the sun in that footage. You just can't
Would
do it.
you agree that the part of the sun we see is at least twice the size of that ship?
I haven't looked at it, Brian, because as soon as you tried to get the angular width of the sun, I was like, you can't measure it in that footage. It's more than half set, so you can't even see the sides of it. And it's distorted as fuck.
I like you and everything, man. I really enjoy talking to you and stuff. And that, I think a lot of people share that, you know, but sometimes, dude, you get like, because the other day, man, you said you was going to send, because I showed you that the ships do look similar, but there's a gap between the one that's 34 miles away, where you could see the sun through the gap between the smokestacks and the wheelhouse, and the ship you posted doesn't have that gap. And you said you were going to get back with me and said you're going to try and get a picture from a different angle. I still haven't seen that.
Yeah, it's in Discord, 6th of August. I found the identical build of ship called the Hyundai Class KR and found a perfectly side-on photo of a ship called the Panther Max.
Dude, you challenged Rook to a pixel count fight and lost.
Bad. I mean, bad. It ain't even close. It ain't even close. I'll post this video as best as I can in X for anybody who wants to see it. But it's not even close, man.
It's the same build of ship.
I'm talking about the sun, the size of the sun. Okay, to build a ship. So you're saying that the side-on view that you posted with no gap between the wheelhouse and the smokestack, you're showing me a different side-on view? Maybe.
It's a side-on view.
Yeah.
It's a side-on view of the same build of ship. It's a Hyundai Class KR ship.
I want to see the same build of ship. You showed a picture of that exact ship. They're all a little bit different.
Right.
I mean, they're pretty similar, but there's a gap. Like I said, there's a little gap in the one you posted. That gap ain't there. I mean, so you're saying you got a picture of that exact ship?
No,
or
right.
that type.
There are only like 60 photos on Marine Traffic, right? And out of those 60 photos, none of them are from perfectly side on. There's always a little bit of an angle, right? So I went searching for that type of ship, found one where there is a photo taken from perfectly side on. Yes, there is a gap. It's in your DMs in Discord.
Also, if you look at the speed, I mean, oh my God, dude! At least go review that. At least go review that video again, man. Before we have this discussion. Okay, the speed of the one up close. What the one up close? What's the distance of that?
I deleted the freaking spreadsheet. I could go and work it out again.
Dude,
I think
how
it was
dare
13 Ks an hour, something like that.
Throwing away perfectly good spreadsheets.
Well,
it
you
was
can't win
going
them all, Rick, man. You sucked at Globin that day, bro. That's 2 days you really sucked at Globin, bro. You're usually pretty good at it, man.
You show me the frame. Post the frame of the video that you use to get the width of the sun. Please do that.
Yeah, it's not even close. Why would I have to? I mean, it's not even close to the size of the sun. It's smaller than half. I mean, like I said, I just wanted to, this was an honesty test. I wanted to see if you would even agreed with the amount of sun that we see. Would you agree that ship is at least no more than half of the size? Because I mean, I wouldn't know how to respond, man. It would have hurt my feelings if you'd have responded any other way. You could maybe say the sun is oversized or something, maybe.
No, that's
But
the other way
the
around.
ship is obviously way smaller. It's supposed to be the same size, the same width as that sun, and it's not even half as big, so it's not worth counting, bro.
Because the sun is not half a degree wide in that footage. Show me the frame where you are measuring the sun. It cannot be done in that footage. The sun's more than half set and it's distorted as fuck. You just can't do it. Hey, chicken.
I think that's a mic drop.
You didn't hear it, but my soundboard just said "gay" from the back. So you know.
It's distorted by about 25%. I just did some pixel counting of my own Rue, and when I do the giving it the benefit of the doubt all the way through there, the minimum we're looking at is about 2,500 feet of mountains showing, and it's probably another 25% beyond that.
Yeah, post it.
Post it.
Hey,
See,
Shane, I'm gonna
couldn't get
post.
you to do it, but I'm gonna.
I'll do it.
Right.
Give me 5 minutes and I'll send it to Alan or something.
Dude, someone had drop a pixel fight or whatever. Let's get down to it. Ralph, pixel fight, me and you, bro. Tomorrow at the playground.
I got MS Paint open and the
Well,
magnifying glass is on maximum.
We'll be streaming it. We'll be counting them up. I'm gonna win.
I recommend Stone look at the pixel fight that I just brought up, man, and not going to chip off Ruhib's shoulder because it's a no brainer. So I guess Ruhib's going to have to claim that the sun is about a little over twice as big as it normally is, and if he's willing to claim that, man, that puts into question mother.
Brian, I think you're underestimating. First of all, I wouldn't challenge Ruhib to a pixel counting fight. I think you're underestimating, first of all, how much time and energy he'd be willing to put into some sort of endeavor like that, as I think he's been proving. And second, it's the same guy who just said that he'd argue with if you're an infinite radius, also that doesn't matter about coefficient of refraction, but literally can see your own butt again, right? And you're gonna argue pixel count with that. Good luck, bro.
Hey,
Yeah,
sorry, real quick, while the Bruce Ferret is gone, I just wanted to say that, hey, later maybe everyone can say a prayer for Sacred and for Proud, just for what.
Absolutely.
Also, just wanted to make a quick little, for anyone that.
You're breaking up.
Why
there,
is it
Lily.
always her?
Yeah, you keep on going in and out, Lily. Can't hear you.
I did hear the prayer part, and I'm glad to say a prayer for them.
Absolutely.
Now
I can hear you.
Let me see.
There you are. Maybe. Maybe not.
She's still there?
This always seemingly happens
Can
to
you-
her.
Yeah, now
Can you hear me now?
Yeah.
Yeah, you're good.
Go. It seems like we can only hear you when you say, "Can you hear me?"
Yeah, it's kind of bizarre.
Oh darn! I think I lost connection.
Oh.
No.
You only lose connection
let
when
me
you're not
see.
saying, "Can you hear me?" Okay, wait,
Yeah,
hold on.
you're-
Can you hear me? And there it goes again.
Never been more clear.
I think Lily Hanna needs to
Okay,
exchange
I'll try
some
to-
heated words with her ISP.
Oh god. Hopefully you guys can hear me. Can you hear me?
Loud and
Loud and
clear.
clear.
Okay. Okay. I just wanted to say for anyone that's new over here is that, the 5 teachers that we have here are not just ordinary flat earthers. These people are extremely knowledgeable. And I'm learning so much, and it's incredible. It's such a joy to learn. And you really learn a lot of facts about our world and what it really is all about. And they present it to us in a way that, we can understand it as lay persons. And so I wanted to, for anyone that's new, I just want to inspire you to check out their information. I did post something in the Purple Pill about them. It's the 5 teachers, which are Stone and Alan and Whitsitt, Shane and Toby, and all their information is there. And there's an ancient tradition in India where when you have a teacher, you always show your appreciation because it really does improve the learning and it improves the teacher's teaching. So you create this really beautiful kind of an exchange, like this really beautiful revolving, reciprocating exchange of knowledge and appreciation. So I encourage all of you to, open your hearts and your wallets and support them. I didn't realize in the beginning when I was first new to this space of how important the information they share is really to keep the flat earth understanding and the science going further. And I know they're making clones of themselves because I hear TM and I hear Ken and I hear Nicholas and I hear so many of all of you over here, Indio and all of you, so many of you. Like, you guys are learning so much and picking up so much, and soon you're going to be clones of these teachers, which we need, and then you'll make more clones because we need more teachers. Because I can just speak for myself that learning about flat Earth has just made me way more fulfilled as a human. And I always used to wonder about certain things, about why we can't feel any emotion at all. And I realize I understand, the science so much better now. So yeah, I just wanted to inspire everybody to take this seriously and really learn, because there's so much joy in learning. And then you yourselves, can talk with some level of authority, right? We won't sound completely dumb and people won't think that we're total morons. I'm picking up a lot. So their YouTube channels, you should go to their bios, and the Bitchstone has BitChute channels, and they have so much content. It's amazing. Like, we don't even have time to go through all the content that they give us, and they give us all this for free. So let's show some love back. And it's really for the children, it's for the future, so that our children and grandchildren have the option to learn flat Earth and not just learn globe Earth. I think they should learn both, because why not? Then they'll know how foolish globe Earth is, right? So anyways, loads of love. And I hope everyone's well. And don't forget to pray for Sacred and Proud tonight. I love you guys a lot.
And that, gang, is why this is our ambassador.
Right there.
Right there.
All right. Do you want to do Canagoo for 5 minutes?
Oh, I had a funny thing happen with some Globers last week. They were complaining that, oh, you guys are all Nazis and this and that. And I was like, I didn't go on, I didn't type about it, but I just wanted to share that, when in 2021, when the whole COVID thing was going on, I literally had Globers telling me that they, thought I should be caught and held down and injected with the vaccinations. And I was like, holy cow. I said, are you really that disrespectful of my bodily autonomy? It's like, I was shocked. But I didn't write all the Globers off. Like, I know not every Glober would ever think of doing that. So any Globers that are listening, please, we are not, just because one flat Earth person came off as some kind of an, authoritarian, that doesn't make us all that way. So let's just leave the politics out of it, and let's stay focused on what we're talking about, which is the shape of the Earth and the motion of the Earth, and how you guys, really, the burden of proof is on you guys to show us that we're on a spinning globe. That's all.
I did notice that there were a couple trolls trying to socially shame you into defending others people more positions and accusations on the spot, and I did note to myself at the time that you handled their retardation admirably. So that was cool.
What's happening?
All right, can we do Canagoo for a couple of minutes? Because I got to go shortly.
Yeah, 1 sec. And that's why Liliana is Madam Ambassador Royale of Flat Earth.
But about to get a promotion too.
Here, here.
All right, boys, let the Canagoo commence before Ferret has to go. Someone Canagoo this man. Do you need me to share anything for you, or you got it figured out? All right, send it on.
Is he bringing his drawings? What's going on?
Yeah, I made a drawing.
Oh, did you already send it? Is that it on telly?
Yeah.
We got some authentic Earth.
TM, you can take my mic back. I don't need it. Thank you.
I need to stay for now.
All right. Oops. 1 second. What's your Twitter handle? Bruised Ferret?
Bruised Ferret.
Could you just make it Ruhif and stop confusing everyone? It's very
Someone's got Ruhif.
Really? Someone already made it Ruhif?
Well, some Rui. It's like an Indian Pakistani name or something.
Yeah, just tag that guy. So
great.
He's gonna be very confused. But your pictures are now in the appropriate designated spot.
Also, Clone Lads Assemble.
A in the jumbo.
Oh,
Ruhi
sorry.
Fatima 09.
Yeah, that was the wrong post. 1 second. Putting the right
Oh,
one
it doesn't
up
matter who
there.
tagged, whatever.
Are you going to retag the same Indian guy in the second post?
Absolutely, for continuity, of course.
Yeah. I
Nice.
figured.
Let's see.
Bruce Ferret. I mean,
Oh, hang on, 265. Hang on, it's 265, I think. Oh, that's the wrong one. No, incorrect. Sorry.
Couldn't you be like Ruhif 2?
Do you need a are those both pictures the ones you want to send? Those two?
No, they're of a different Canagoo observation, so they've got different distances and whatever. So,
it's a no-go on this or what?
No, just the first one. Just the first one I sent you. So that's the one.
All right, I just
that we're
posted them
looking at.
both. Good luck.
Oh, doesn't matter. Yeah. They're from different locations, like 20 Ks further. Right. So the sun has a known angular size of 0.53 degrees. We can do some pixel counting to work out how many pixels that is. And on that screenshot that I took, it was 771 pixels. Then we can measure how much of Canagoo is visible above the horizon. And that was 180 pixels on my screenshot. So we can work out the angular size of what part of Canagoo is visible. And if you know the distance and the angular size, you can work out its actual size. And if you do all the math on that, there is 528 meters visible. That's a 2,000.
Somebody's not very good at math. What angular height do those mountains show to you then?
0.124 degrees.
Yeah, try closer to 1/6, but you're getting there, Rue. You're getting there.
Well, show us your screenshot which has 1/6. I mean, I can draw arrows on it if you like.
It's the same one at about 18 seconds through the one Sacred posted.
Are you measuring Canagoo, like just to the right?
See,
of
the shot you're looking at here that you posted, the full sun is not even visible. So you can't actually tell me how compressed the sun is away from circular in the image that you chose.
We talked about this 15 minutes ago.
That's it again. That's it exactly. You see, that's where you're screwed. Is you're going by the width.
Yes, because it doesn't compress.
Yeah, you pretend all you like. Go ahead.
Okay. Okay. We all know you're a liar, Stone. So, you know.
Ah, the way you toss out the libelous terms. You're such an ass.
What is the dark bottom? What is the dark half of that photo?
You're pretty smug, someone who can't do anything about telling us how you measured the sun other than triangulation.
Oh, you haven't met the king of globers yet, dude?
The bottom half of that photo, the dark part, is that water, Stone? Is that the ocean? Everyone here knows.
Like I was saying, no, it's not.
Okay.
It is merely what this camera is able to show you.
Okay. How about we post something just before sunset from another observation?
Do you think those mountains are just sitting on the water and there's nothing else to consider?
There's
no other land anywhere between us and those mountains in the shot. Do you really think that's what's going on here? Because it isn't.
Another one. Hold on. This will be fun.
Wait, I got a question. So Ruiz is using his own image and not referring to the video that we put up top?
No, he's using an image.
He decided to take it off.
The entire sun, yet he's using the sun as the metric, and it's retarded.
Hang on, can I?
Yeah, but this photo is not even matching the one that we have up top. The video that we have up top.
I got the original video, so
amazing. Work on using that.
Say again.
Work on using that. You're grasping when that mountain should not be visible at all. I don't even know why we even allowed you to further this conversation in this direction.
Right. When you say it should not be visible at all, are you ignoring the atmosphere? We've been through this.
It should be hidden by 10,000 feet of curvature. A 9,000 foot mountain with 1,000 foot observer height should be hidden by 10,000 feet of claimed earth curvature.
Okay. Are you ignoring?
When you factor into the atmosphere, you have to demonstrate. You have to demonstrate that. Otherwise, it's not science.
So when you keep saying, you keep on trying to say the atmosphere, that this mountain on your ball should be sitting sideways, and somehow it's getting refracted up, so it's nice and level to where we'd see it on a flat plane.
What do you mean sitting sideways?
Shapes here.
What does sitting sideways mean? What do you mean?
You're on a ball, man. Do you not understand what you're living on?
Do you mean leaning back?
Yeah, sideways.
Okay. Right. Well, I wouldn't call it sideways.
Well,
Call
it
it
would be
leaning back.
sideways. When it comes
From one's perspective relative to that, yes, it would be sideways.
Right. How much is it leaning back?
You tell me, man. It's your ball. It's
Well,
your.
you're the globe expert, right?
No, you're the globe expert.
That's true. Correct. Right. So how far is it? That one's 244 kilometers.
You tell us why it, like you said, it's 10,000 feet of curvature there, and the top of that mountain to the top of your curvature is 1,132 feet of play there. That mountain's below that.
Right. So it's 244 kilometers away in that footage. All right. So it should be leaning back how much?
You tell me, mister.
2.2 degrees.
It's not leaning back any. You don't think on a ball it'd be leaning
that's
back?
the question. That's the question.
Huh?
Right.
Your ball doesn't.
2.2 degrees converts to how many feet? How many miles?
2.2 degrees, or cosine of 2.2, is 99.93% times 2784 meters. It would lose. Oops, shit. It would lose about 2 meters of height due to leaning back.
So we should see it, inclined backwards. How much?
2.2 degrees, which would change its height by about 2 meters.
Show that lean.
Show the what?
Show the lean. Show the lean backward.
Lean. Do you think you can look at a photo and distinguish between something perfectly upright and something leaning back 2.2 degrees?
You said it's there. Show it. Can you put? Can you draw?
No, I didn't say I could show it to you.
Because it's not there, man.
No, can you look at a photo and distinguish between something perfectly vertical and something leaning back 2.2 degrees? Can you do that?
Did you just get stuck in a pixel fight with Rohit after I specifically made that proclamation and chastised Brian about this?
Fuck, I gotta go. Yeah, basically you cannot see the lean.
So can you show? Seeing how you we're gonna go. We're gonna revert back to you showing us something where you refracted a silhouette.
Yeah, I will put out the video tomorrow, 24 hours time, which will just have the same explanation I gave anyway. So
I can't wait till my notification goes off.
You can mute your mic, then we'll see you tomorrow.
Yeah, cool.
Bye.
Thank you guys. Love you, Shane. Love you, Alan. And Stone, you're a liar. Bye.
Wait, Bruce, wait.
He leaves with slander. This guy.
What a dude! That's Ruiff, dude. That's the king of the fagularity.
Everybody's
popularity or whatever.
Tomorrow, same bat time, same bat channel. We're gonna see ferret face, refractor shadow.
Is that what we're doing? Friday tomorrow? Oh no, you're just saying that because we're gonna have a party for his when everyone who subs to his channel is gonna have it go off. We're all gonna get together. We're gonna watch the new arrival as it premieres with bated breath. Or we're all gonna forget what he said immediately. I don't even know what he's making the video about. Honestly, I already forgot.
So when do we get to say hi to Flat Earth Dave, who's hanging down there listening to us?
Is Flat Earth Dave here too?
He's probably here for Ruhiff. Now that Ruhiff's gone, he might get at it.
What's up, Flat Earth?
Definitely a Ruhiff fan. Ruhiff's got quite.
You gotta hand him a mic first.
I could drop down if you need mics.
Ralph, what are you doing up here still?
No, there's one open right now.
He doesn't know. He's been hanging out with me all day long.
Actually, I
Hey,
don't.
Nick, I'm gonna drop down real quick. My app is glitching.
I don't hate Ralph. Ralph, you're cool with me.
Ralph smokes weed, so he's all right.
To be honest with you, the globe Earth is flat Earth is not that important for me to have any vicious feelings against any of you. I mean, this is just I don't know. For me, this is my form of relaxation.
Well, explain your.
Golf, I'd rather fucking do it.
Why do you get vicious emotional outbursts when I correct you on things? That doesn't make sense.
Oh, don't assume by me getting loud, I'm getting emotional. No, I just need to keep up in the room.
Okay.
No. I mean, like you guys heard me say many times, this doesn't change anything on my day-to-day existence. So why would I even allow myself to get that emotional about it? Can we get loud? Yeah, we can get loud. But am I going to go over here wishing malice on you? No, absolutely not. This isn't that crucial to me to have that type of emotional investment into it.
That's cool.
Are you getting loud, Ralph? Are you about that life, son?
Loud and rowdy, bro.
Trying to get rolled up on by some flurfs or whatever? I'm just kidding.
I started talking about dropping the 6 trillion. Things got crazy.
Everyone, happy Friday.
Notice Bear.
What's up?
Stone, I just want to say, if I were to describe you as an instrument, I would not describe you as a lyre, maybe a lute or a harp.
Very nice.
How about a saxophone?
Dude, a rock with a saxophone.
People who've heard me play understand that joke.
Sax is way too cool.
I don't know. Stone's pretty cool.
So the spotlight today is nobody has been able to refute Mountain Canada.
Well, I don't know. If you count the pixels and then do some math and then count some more pixels, it's pretty convincing that Shoot, what was the point of counting pixels again in the argument? I lost my place.
I don't know, but he said tomorrow in 24 hours, we're all going to be devastated and have to, live on a spinny space rock because he's going to refract a silhouette.
I never thought that a drawing would be the end of flat Earth.
Dude, he said he's making a video about Witsit, so we should all like hold our breath and be like, "Oh, I can't wait to see what Ruhev thinks about Witsit," who hasn't like mentioned Ruhev once or ever in a stream or made a video or whatever. But can't wait to see what he says about him. Like, ooh, drama,
Well, I think he said he's going to do the drawing for refracting the silhouette to refute Witsit's claim of Mount Canada.
Yeah,
Something tells me he's going to call him a liar.
Well, here's what you do, right? You do nothing, and then other people will watch it, and then you'll get told a brief summary in a text format, and then that'll be enough.
Everybody starts throwing the word debunk all over the place.
No. Like, wait for a real person to watch it and tell you if it's valid or not. That's all you gotta do.
Refraction. So you're saying refraction doesn't exist, huh?
If it's legit, someone like Brian Lee Keelstone would be like, "Hey, bro, come here. Listen, this guy, right? He's an asshole and wrong, right? But he made some points." That's what'll happen, right? Your intimidating white noise is doing it again. Nobody knows. Should we speak?
So
just pretend you're a dog and cut me off. I don't care.
Sorry. So who else lost it at Ferret Face? Like, I was rolling after Ferret Face.
Dude, I was kind of rolling, but then I was like, I've never seen Nick get so upset. And then when he heard it, when Ruhev heard it, he was like, I got him. I'm going to just keep pressing that. And then that's when he was like, fuck you, right? Like, immediately he's like, dude, I'll outgay you in a second. So you can't go down that road with them, right? Like, so...
Not going to beat a professional troll.
Yeah, like, dude, I wouldn't recommend it, right? As a proper bat.
And we obviously went to the moon because I couldn't even hear the laughter after my joke. So I'm going to drop down.
Nice.
But that was a shout out to MASH for all you people that are old. You know who Ferret Face is.
Oh, I thought you would just like fuck your face, like making it whatever his name was, a stupid face.
No, he's
or
talking
whatever.
about Larry Linville. Larry Linville, no less.
I'm not that old. I guess.
No, when MASH used to come on was 11:30. That's when I knew it was past my bedtime.
Yeah, the character's name was Major Frank Burns.
Major Frank Burns.
I used to think that's when all TV ended because it went to black and white garbage, and I went to bed anyway.
I used to hate that show.
Okay, so here's some trivia for that show. See who's been really paying attention to MASH when they were watching it. So Frank used to send letters home to his wife. And in order to ensure that the wife knows that the letter's coming from him, what would he also put in the envelope when he sends it to her?
Toenail clippings.
Close.
Something like that.
How do you take a guess like that and not be right?
No, it's close. It's the
How is
other
it
end of the
close?
body, though.
It's
other end of the body. his nose hair clipping.
No, there you go. Something like that.
Yeah. how about that?
In what way are nose hair clipping close to toenail clipping? So is it
It's something
proximity
he
or?
puts in the envelope as code that you know this letter's from me because it has that in it.
I'm sorry, I asked.
In the movie, everybody hated that character too. Everybody hated that character too in the movie. Yeah.
Did you see the episode when he tested her and he sent some hair shavings instead, and she replied back and he divorced her for not following the code properly?
yeah.
MASH.
Wait, what show is this?
MASH.
Well,
Mobile Army Surgical Hospital.
I got more trivia for you. When they're shooting the show, it's actors and actresses everywhere, regulars and not so regulars. Out of all the cast, which actual actor is the biggest dickhole on the set?
Alan.
Typically. Nope, not Alan.
Radar.
Correct. It was indeed the guy who plays Radar, that meek little character. He was the biggest dick on set.
So, did you know why he always carried a clipboard?
Gary Berghoff.
You know why he always carried a clipboard?
No, why?
Because his hand was deformed.
Oh, trippy. That's neat.
Yeah.
The old hide
I
your
think the
deformity
only time you
behind the
notice-
clipboard trick.
Yeah.
I think the only time you can notice it is during the opening sequence when they're playing catch, and you could briefly see it for like fleeting seconds, and other than that, he's always covering it.
So was that the first mainstream show with a cross-dresser?
See, and the funny thing is he was trying to get out of the Army. Now you cross-dress, you get into the Army. So times have changed.
Yeah, the old flippity flop.
What about that show? That show Soap had a cross dresser. I don't know if it's older than MASH. That's probably about the same time.
What show?
Soap.
Oh yeah.
That was a fantastic series.
I love that show.
Guys, MASH is pretty gay. You want to talk about Red's rhetoric, anyone?
Fuck Red.
You know, he's dick. Speaking
Okay, I agree.
He blocked me.
What? Redliner's in here? What is that fucking right?
I don't know. He blocked all of us because he's terrified of having a confrontation.
Very extremely. My favorite part was when Alan used his evidence against him in that debate. That was beautiful.
Yeah, I think that's why he hated us and then specifically ignored Alan in the corner of his screen with all of his evidence looming over his shoulder like a big dick in the room. Dude, he was just like, pretend not to see him.
And then he was in his space with his little buddies telling them to tell Alan to come at him or to call him out or some shit. Instead of him doing it directly, he's telling his little minions to do it.
He's like, hold me back, guys, hold me back. All right, I'm a crazy guy, you know?
It's pathetic.
How cool is it though that the evidence he tried to use against Shane mid conversation, right now later was absorbed into the thing that defines everything for optics for us, so we can swoop up everything they've ever used when it comes to the sky.
Tried to hurl an angular resolution formula at me as if it was an attack, not knowing how to scoop it up and immediately reapply it, of course.
To be fair, I'd like to know what the difference is between refraction and albedo effect.
Albedo is a reflective value. It's got nothing to do with refraction. They're not even the same animal.
Probably uranium.
So which direction does something refract? Is it up or down?
Well,
it's the more dense.
If you listen to Ruif, under 100 meters, always towards the more dense medium, downward, right? Always downward.
Gonna put it wherever it needs.
But yeah, in reality, it's wherever the fuck we need it to be. And then my math says that wherever you saw too far, that's where the Earth curve was. Retroactively, of course.
Yeah, unless there's a temperature inversion, right? Because then it goes up. And send up some balloons, bro. That's how you're gonna know.
Send up some balloons every day.
It doesn't have a limit, right? Like you could theoretically refract 50,000 feet.
No. Yeah, that's why Mike.
Yeah,
Mike.
you can like look through a really powerful telescope and look at your own sphincter in the other direction.
Yeah, the Riv is famous for claiming that under 100 meters, he will literally argue refraction of a sphere of infinite radius, which is flat, literally like 100%. If I look through my legs, I could see myself, right? That's what he'll argue. That's why, like, I was arguing with him, and then I was like, I forgot about your position and why I don't care. Like, this is a retarded argument from my position. There is no way to win. So, like, it's pointless.
Yo.
Piezo, there he is.
Yo,
Piezo, sorry.
Piezo, what's up, brother? Was thinking about it
that's
earlier,
I said it
man.
wrong.
What's up, man?
What's going on?
Yeah,
Dude,
bro.
our flat Earth circle jerk is complete. Thank you, buddy. Now it's all of us.
Sky Free's got a pretty damning observation, man, when it comes out refraction and the way the globe claims that it works, because they do a temperature measurement with a short range laser, and it shows the colder air above the ground where the laser's at. The higher it gets, the colder it gets, and then it disappears. So if the light's refracting up toward the colder air, there's no way for it to get past your eyes and set without it crossing your eyes. You know what I'm saying? It's pretty damning. I'm gonna see if I can find it. But if their measurements are correct, then that's a real bummer for the globe.
I just wanted to add a tidbit I just read from the chat. Secrets of Heaven. He said Alan Alda from MASH is a flat earther.
Oh, there you go.
Well, that's trippy.
Shout out to the MASH lads.
The MASH.
That is trippy.
What's up?
All right. Who on Gilligan's Island was a flat earther? Now, sorry, I'm kidding.
Yeah.
I don't care.
Wait. Gilligan is not a flat earther.
Yo.
Oh, I hope it's Ginger. Let it be Ginger.
Yo, Shane. So I was thinking about gravity, man, and I was thinking about Newton's laws of motion, like the second law of motion in particular. You know the second law of motion, right, Shane?
What goes up must come down.
No.
I'm just
The
joking.
second law of motion is F equals ma, and it describes the relationship between a force that gets applied to an object and how it results in an acceleration. The greater the force applied, the greater the acceleration will be. But in particular, in the second law of motion, notice that the acceleration is the result. It's the effect. The cause is the force. So you know what that means, right, Shane?
Ooh, I hope you're going to tell me.
Well, it means, Shane, that when it comes to everything in the universe, if I want to make it move, if I want something to move, what do? I apply a force, right? But hold on a second. There's this one exception in all the universe to this law, apparently. And apparently its name's gravity. You know what that is, Shane?
No.
Well, you see, the thing about gravity is if I take two objects and put them side by side, okay? Two objects of the same size, side by side, same height above the ground. If one is like 100 times heavier than the other, right? Then I should expect, if I apply a force to the heavier one, it will have a smaller acceleration. And if I apply the same source, the same cause, which is the force, if I apply the same force to both objects, then they should move with different accelerations. But gravity is the exception, bro. Yeah, but gravity is the exception. Because here's this thing. When gravity, which is the source, it's the cause, it's the force, right, touches both these objects side by side, it's not that they have different accelerations. Somehow they have the same acceleration. Meaning that the force is different on each object. It's a different force. It's a uniform acceleration. Now, if you think about this, what does that say about gravity? Could gravity be the cause? Because isn't the thing that results the acceleration, isn't the acceleration the effect? Because if gravity is the cause of the F equals ma relationship, then it should be the force. So how do I have the same force applying different forces? See,
You're quite correct.
It points to the idea that there's a different source. Now, if I think about it in another way, what else could be the cause if gravity appears to be the effect of the relationship?
Yes.
All gravity is G. It's A. It's A turned into G in F equals ma. Well, if I think about the electric force equation, what does that say? Well, it says F equals Q vector E, E being the electric field, but F equals QE. So that says that Q, which is the charge, times E equals the force. And now, if I put an object inside of an electric field that has a certain charge, it will experience a certain force. Now, here's the thing, though. That makes the electric field precede the F, which precedes the A. But here's the other thing. If I take F equals ma and I put that on the left, and I say F equals QE and I put that on the right, so that I have F equals F and ma equals QE, you take the m away and you put it on the right and put it underneath the q. So you have A equals Q over m times E. Now what do I have? Now I have the acceleration equals the electric field times the charge to mass ratio.
Oh, someone's trying to solve for ether density or something, or ether.
And they rule out any negatives too to even help that out.
Now, what does that equation tell us? A equals Q over m times E, charge to mass ratio times the electric field. That means that objects within the same electric field, in order to have a constant acceleration, you have to have the same charge to mass ratio. So in order to make acceleration constant within the same field, you need the same Q over m.
Dude, is that Coulomb volts per meter?
Well, no.
Per meter.
It's this relationship at which the way they teach you to use it is with surface charges, because surface charges will produce an electric force inside of a capacitor. But what about matter itself? Because hold on, matter is made up of charges, right? Electrons, protons, and neutrons. But the same total charge of every stable atom is the same. And it's made up of the same charges, which are the building blocks, which have the same mass. So every atom has the same charge to mass ratio of its gross charges, gross matter charges. So if you think about it, if you had a big enough capacitor, right? The bigger capacitor with the smaller capacitor inside, if Earth's the bigger capacitor, then it is controlling us by our overall gross matter charge to mass ratio. And then we have another capacitor that we test in the lab that we have, which is also physically made of matter. And so we create this charge field, and it's going to affect something, by its surface charges. But what about the inherent charges? Is the reason that acceleration is constant on Earth, that the gravitational constant is a constant acceleration on all objects, even though they have different mass? Is it because their gross matter that they're made up of has the same charge to mass ratio at an atomic level? And thus, that's why within the same electric field, i.e. Earth, they experience the same acceleration? Is that why falling objects have that relationship?
What is the heaviest known element?
You mean most densest element?
The heaviest known element.
Osmium.
Polonium.
Uranium.
I think it's the densest. No. I think osmium's actually denser than uranium.
Yeah, I do believe it's osmium.
But it's an extremely rare earth metal. But
Uranium is the heaviest naturally occurring.
But how does that relate to what we're talking about?
yeah,
Mass attracts mass. So the heaviest naturally occurring element
He just
is uranium.
demonstrably disproved your assertion that mass attracts mass, though. It was the first thing he did.
Wait, Barbara Dan's he's not a glowy.
No, it doesn't matter what his beliefs are. I'm just talking about what just happened here and the assertion he made.
Who asserted mass attracts mass?
That was Dan talking about that. He missed the first premise that Pisa laid down. Yeah.
so yeah, I don't know. I think that's my new way of thinking about gravity. Now I wonder if you were to use that, right?
Wait, so real quick, when they misapply it, they're like, that's not because it would be inverse proportionate to mass, and it's not, and that would answer that specifically, right? And it's like, well, charge to mass ratio, density wise, would still yield that it would, right?
Well, dude, check this out. If you were to use that equation, right, and then you were to rearrange it again, you could solve for Q by putting G over ME. Or sorry, it would be mg.
Fist! I said fist!
Equals Q.
I'm not so sold that all those variables are equally seamlessly translatable the way you're juggling them around.
Well, the E
arena
is
to
Earth's
arena. You know what I mean? I'm not quite there, Pizzo.
The E is Earth's electric field. You plug it in if it's known. If you can measure and isolate one variable that's unknown and measure everything else, the kinematics hold true. It has to be like true on both sides of the equal sign. That's how like an equation works. It equates one side
Yeah,
to the other.
but when we talk about electric field dynamics, we're talking about radial calculations most of the time that attenuate according to R squared. And we are existing within a gradient that is a significantly different geometry than that.
We have a vertical electric field on Earth.
Yeah, and it's zero kind of neutral-ish down here as opposed to up there in terms of voltage potential. And it's linear in terms of the gradient. And it's lowest down here closest to the surface. It's different in those two very fundamental ways.
Yeah, but if we're in it, are you just talking about a question of measuring it?
No, I'm talking about the translatability of the variables you've been using equation to equation. One from Newtonian, one from not. You know what I mean? I'm not so sold on that seamlessness there.
Well, they all have to be universally true all the time, or else the equations aren't true at all. Like that's how they work. So if it doesn't work, then
Well, there's a difference between things being true and seamlessly translatable, which is what I'm talking about, Pizzo.
Oh. You can test these equations if you don't believe that they work. I don't know. Taking Q from one side of the equal sign to the other doesn't break it. It would still be the same Q, just like it'd be the same M and the same A and the same E.
You're pulling from one formula and dropping it onto another formula, and they are to do with two different mechanistic processes. And I'm saying that the geometry of the one formula does not resemble the geometry that you are eventually applying your modified formula to. That it's not quite as cut and dry as how you're drawing
What
it. That's all
modified
I'm trying to
formula?
state.
This is not the one from Discord that I like shared with you, bro. This is MA equals QE.
We're just talking about what you talked about here. That's all we're talking about.
Well, I didn't make this formula up.
Well, there's one formula that involves and invokes mass, and the other one that does not. That's another fundamental difference between the two arenas that I'm saying that it's not as seamlessly translatable as you are implying.
So are you saying I performed an illegal operation or not, brother?
Kinda, yeah. You stepped over the line a little bit, but I like the direction you were heading. The first part is irrefutable. It's just where you went to from there, I'm not so sold.
Where I moved E to the other side of the equal sign?
You did the algebraic hokey pokey.
That's how you do
That's how you do it, man. Come on, Pizzo, ease up.
Yeah, I have a fundamental disagreement that you can't just divide by a variable on one side of the
naturally.
equal sign and put it on the other.
Yeah, you got to do both
Actually,
sides, man.
but you're ignoring what I'm saying, Pizzo.
You can only add and subtract both sides. I mean, if you add to one, you got to add to the other, right?
Yeah, I mean, are we on a level where we're not Okay.
Hey guys, if I may interject,
Certainly
I don't want
not.
to jump the gun too quick.
Nerve.
Hey, this may have nothing to do with
No, I said
the
certainly
outcome
not.
of what you. Oh, okay.
Man, y'all made me run over a frog, man. Which y'all bullshit. No, I'm just kidding.
Get these big fonts on here real quick.
Someone talking.
No.
Really went quiet.
No, Pizzo is tossing his variables around to try and make better sense of them, and I don't think he's going to get there.
I'm just making a graphic in Paint right now real quick. Just give me 1 second. I'll share it with you.
An almost accurate statement is that you're mixing domains.
You can equate forces to each other physically, like in the real world. Like the explanation for why you can do it is because energy is the same and it takes different forms. But like, when you have an energetic input, like it doesn't matter if it's one type of energy or another type of energy, you're still transferring the same amount of energy. And when you transfer a force, you're transferring the same amount of force, whether it's in the form of kinetic or electric.
On one side, you're interplaying your force against mass. And on the other side, you're interplaying a force against electrical charge for charged bodies. The mechanisms are so totally unrelated that it's not right to assume seamless translatability between the two formulae like you are presuming. Don't look at the letters anymore. Just hear what I'm saying, Pizzo. He's lost, boys. We're never going to bring him back.
I've almost got my diagram done.
While we're waiting, what's up, RG?
Hey, hope everybody's having a good night, man. I think what I'm not the smartest guy in the room for sure, but I'm kind of hearing that he's saying interchanging the energy of something and the mass of something is interchangeable, but I hear exactly what he's saying and I hear what you're saying. But it kind of goes back to when you're consciously observing something to solve for.
Yeah, we lost you there.
We lost you, man. Got zapped in one of them gravity pockets.
Net Damon took him right out.
Forwarding it.
Ah, he's back now. So, gee, you're going to have to repeat that last 20 seconds because we didn't hear it on this end.
And we missed the last half part.
Okay, I'm gonna try to stay close to the phone here. It's a little choppy on my end. So I was saying, I get both of y'all's observations, the way you're viewing it, and he was speaking of interchanging mass for energy and trying to play with it that way. And so observations can be different when they're observed and when they're not observed, between waves and particles. Now, did
we lose him again?
We got you up to waves and particles there, G.
Yeah, we heard waves and particles, and you ditched. Don't let technical difficulties persuade you. Called the moon in.
Okay, I got you. I think it's because my fan's blowing at the house. I can't get up to cut it off, but I'll try to make it quick. So when you're observing an outcome and during the when you're not observing it, and in that interplay of trying to interchange energy and particles. Now, does that have anything to do with like when you're observing it and when you're not, I guess you would say?
I don't think that's germane to the conversation we're having.
Okay, I got you. I'm gonna listen a little more.
All right. How do I share this?
You can post it in a tweet.
Yeah, just tweet it.
Yeah,
And go and upload it to the nest.
Yeah, just post it down there in Purple Pill.
All right. Paste.
The suspense, man.
I hope it all goes in there. There we go. All right. Stone, what's your username? I gotta tag invention there.
Yep, that's the one.
All right.
You can just go to the up arrow on the tweet, bottom right corner.
I don't. Why did it come back? Why did it come back with a black back? That's so weird. Why is it looking like that? I'm gonna have to do it with the actual screenshot. Made it black. All right. All right, I got you.
My main problem is that Twitter doesn't reverse chronologically post what you post. Doesn't show. I'm looking at your stuff from June 9th and other crap. It's just, oh man, go
All right,
Elon.
it's in the space. In the up top.
in the Jumbotron? I need a second.
Yeah, I'm just loading it up now. Yeah, this is precisely what we're talking about. I don't know why you had to take the time to put those letters up for me. I could already see that in my head. That's what you were doing. This is why I raised the objection to begin with.
Right, but here, check this out. If you do Q times E and you know the object's mass, you will predict their acceleration. Right? So like all of these variables are real in real life. It doesn't matter if I move the Q over to the left or the M over to the right, it's still the same situation happening the entire time. Nothing has changed in reality. So to say that I can't, if I measure its mass and its acceleration, and I measure the charge and the electric field, and all those are plugged in and they're equal on both sides, then if I move the M over to the right or the Q over to the left, it doesn't change the fact that those variables are still real.
Look at the one in the bottom right, just for example, Piso, where you've got MA over Q equals the energy vector of the mass, I assume, of the mass in question.
That's the electric field, E.
Yes, of the mass, right?
The electric field that the mass is in, yes.
Not that the mass is in, of the mass.
No, okay. You take a mass and you place it within an electric field. Okay. That's what I'm talking about. So if I take a particle and I put it inside of a capacitor and, you know, it's like a particle accelerator and its charge is known, this is how they would do that kind of stuff. But we don't need to get into the stuff that is like, you know, we can't verify. You could do this with, you know, your capacitor in your laboratory, or, you know, any kind of a Van de Graaff generator. I think may follow this relationship if it's a I think it's a capacitor. So, but I don't see why like this wouldn't be valid.
It's clear that you don't, and that's okay too.
So if I take a measurement of the motion of an object that I place inside of a capacitor, and I know its mass, are you saying that I'm not going to be able to predict the acceleration it's going to experience?
So in the lower right, you are talking about the mass of the object and the, yeah, okay.
Oh, wait. What happened to the E? Why is the E like?
Yeah, lower left, you are missing an E there. That was kind of conspicuous. That's a lonely
weird.
vector line all by himself.
Yeah,
there.
that's so weird, dude. What the heck? Like editing this image, and I might have accidentally like hit Control Z or something when I was trying to copy it. That's so weird. Anyways. But you don't think that you can predict acceleration with this equation?
I think you can test it. I'm not so sure you can predict it.
Let me
this
replace it.
simplistically.
All right.
Because you're making assumptions about the shape and orientation of E in this electrical field that you have displayed with a single vector. If you want, Pizzo, you can just ignore everything I'm saying and keep going with your thought. Where are you headed anywhere else with it?
Can you? Oh, there it goes. Yeah, man. Well, first of all, I was just saying that this would be the reason why, you know, the acceleration is constant, and you were saying you agree with that, and that's like what I've described here in this equation on here, the one on the bottom left. A equals Q over M times E. It's a charge to mass ratio. Q over M, and in the electric field, that's what like J.J. Thompson was doing, with the cathode ray tube, and he tried to ascribe mass to like what was in there, and that's how they basically said that they discovered the electron. But he measured the acceleration and he knew the electric field it was in, so he's like, here's the charge to mass ratio. But then they did this conspicuous thing with the way that they applied mass to the to a wave and called it a particle. I'm not suggesting you use this particular equation right here to like invent mass for like light waves or anything like that. But what I'm saying is that, macroscopic objects, you could put an equation like this together, and I think that you'd be able to predict acceleration.
This ends, I think, in the way our conversations typically end, where I go, yeah, okay, test it.
I mean, even ChatGPT is agreeing with me. I said
It's like I said, nothing at all, Pizzo.
I mean, okay, bro. Let me Google MA equals QE. Like, I'm not the only person who's thought of this before.
What
Motion
you're
of
pointing out,
a charge in an electric field.
what you're pointing out is your tendency to bargain with the price of proof.
I mean, I'm just on, university websites right now looking at motion of a charged particle in an electric field.
What happened? What are we doing?
Hold on, I got it right here.
I think he's trying to come up with an equation to calculate how fast everything will fall.
Here, I'll put this one in the.
Well, he's got to find a way to quantify Q for a solid object.
That's kind of picky, don't you think? I'm just kidding.
This is
mathematics is a little strict like that sometimes.
Do you see what's in the purple pill? Up in the, I just posted and shared up there.
I'm just loading that sucker up now.
Could you slide harder into my ear, please? I didn't quite get into my back of my skull.
Sorry, bro.
Was it good?
I didn't realize my mic was coming through that loud in here.
Hold on. Hold on.
I feel like, yeah, the sensitivity is probably like too high for like the Twitter or whatever, but
yeah, Discord. Yeah, if you use the Discord, it has a wonderful crisp and it's an awesome noise cancel. On here, you're like raw and bare. So
yeah,
I bet you can hear my wonderful fan going full force.
Yep. Jane's joining us from the ISS, which may or may not be electrostatically tethered.
You like that?
yes.
6 kilometers a second.
He's got the windows down. You can hear that 17,000 mile an hour wind outside.
Guys, I just walked the dog and it's hot, and this is what you get. Like the fan's gonna be on for a couple minutes. It's just the way it is.
Oh, so while you guys are going over the diagrams and whatnot, Eric, our librarian, had a question of interest for you too. He pointed out something relevant to the discussion. It's on the admission exam for Oxford, this question. If you guys want to check that out, it's the diagram shows two spheres of mass suspended by wires of negligible mass. The two links between the pivot points at the center of each sphere is L. The two suspension points lie on the horizontal line and are separated by the distance x. The system is in equilibrium. The total acceleration due to gravity bg. You may assume the delta x is less than L, then as well as for the x to the x. So if you want to check that out, or if any comments or thoughts on that.
Where would we be checking that out?
That's in the Jumbotron, and if you go to the most recent post, you'll see Pizio, and then just slide over 2 posts, and you'll get to mine. And you'll see some spheres from Harvard or Oxford. Oxford spheres, they call them.
Yes.
What is it wanting you to calculate?
This is the GMM over R puzzle, ignoring the vertical component, which we exist in. This is a thought experiment where you're computing torque.
Yeah, Eric said that the B part is the most relevant. So let's see, what was the B part?
So Pizzo, back to what you posted last with the charged particle electric field off of the W something site. Again, this is a very general statement collection about the generic. I mean, it's talking about an electric field. It'll experience an electric force, and that's how these base formulae apply to a simple gradient. And I'm sure you can hear the hesitation in my acceptance that we can just ubiquitously apply this to every scenario. You know what I mean? It doesn't quite follow.
So you're saying that the physics website is wrong.
Oh, come on, Pizzo. Don't do that.
I mean, this is how we predict the acceleration. Like, we use this math in real life, dude. I don't know if you think A equals Q over M times E. It isn't used in reality, but it is.
You can't hear me. I guess that's okay too.
Nick, you got Peter down there requesting a mic again.
Anyone want to talk to Peter?
I've been ignoring him.
I don't think anybody wants to talk to Peter.
All name.
Well, we did give him some homework to do a long time ago. I don't know if he did any of it.
It's a
Maybe
dangerous
he
game.
knows more about relativity now. Once I pointed out, doesn't know the first thing about it. I don't know.
I think he's just going to talk in circles again.
He's gonna word salad us and just start talking about orthogonal datums or whatever.
So, I mean, I can give it a shot, but I think we're all going to be disappointed.
You know how you guys know how they have the force equals big G times mm over r squared, but then for electric force equals k Q1 Q2 over r squared. Yeah, that's what I'm saying, bro. You can that's what they copied. They copied that, right, in order to derive this relationship, and they said it was the mass causing it.
Are you looking for Stone to change his mind, or
I'm just giving you more equation sets where the variables are also symmetrical, just to like show the point.
Dude, it almost seems like when they come up with these constants, that it's like a least common denominator. Like they have to go down to like into the freaking like 6 times 10 to the what's
Don't you?
gravity 6 times? It's
It's
crazy,
a
dude.
Yes, that would
They
be
make it work.
6.67 times 10 to the negative 11th power. Is that the one you're looking for?
Pretty good one. Brian, we just did an episode of Ether Cause about constants, actually.
They also use big M in the Force One chain. They use the big M of the Earth, like that they made up.
Yeah, right. Derived
For
from
little
other
g.
constant. Yeah, derived from little g in the torsion guesstimate, dude.
Yeah.
Go ahead, Archie.
Appreciate it, guys. So I'm kind of curious. Is this just the buildup of force and the discharge of the energy, and it's just a measurement of the displacement of the medium, and it's not really physical? It's just a, you see what I'm saying? Is it something like that, maybe?
It's a big old mess.
Well, some people want to attribute physical properties to things, and some people don't. That's about it.
Yeah. I'm on that medium train. I think the ether's that medium, man.
Yeah, you wouldn't be alone on that train.
Yeah, same here.
I'm on the crazy train.
Hold on, I have some math that from the opposing train going the same speed from the nose of it as if from a radial beam of light, I can tell you what it looks like from over there, but it's not real.
Several
I think
transformations
it's
later.
medium too.
So, Peter, what have you been up to over there?
I've been thinking about the medium.
One sec before we move
Oh,
on.
Christ.
That was a great back and forth, guys. Really appreciate both your perspectives and
Cool, man.
inputs on it, man.
Great.
That was awesome.
Good.
Yeah, that shows our community, right? We can disagree and still have good discussions. Hey, look at that.
Right.
But we're a cult who all think the same thing, so look out,
No, it means that no flat earthers can agree ever.
Yeah, that's the other thing.
It's very confusing marketing. We're a cult, but we can't agree. We don't have guild dues. No one's fucking wives.
Leader.
That's the culty thing about our cult is we don't agree on anything, other than it's not what they say it is.
Okay, Peter, how many more hours of relativity videos have you since watched? And what else have you learned?
Maybe 2 more hours, and I've been reading some papers on relativity.
Name them.
Generalized Theory of Relativity, 1916, author Albert Einstein.
That's one. Cool.
Yeah, that's the one I've been reading. It's not an easy read, and I've been going back and forth between the English and the German original, and that makes things even more difficult.
Looking for swear words that they took out for the English version. Very good, very good.
Yeah, I was actually fixing some of the grammar in the English translation, so yeah.
Okay, so what did you come away with?
Mostly the conclusion that it's the displacement of the medium.
Not sure what you mean there.
Talking about light,
That
Peter?
light,
What are you talking about?
the medium that fills the space.
Yeah, but what is the displacement of that medium? What are you saying?
That density of things displaces the medium.
Like pressure mediation within a medium?
You got this
It doesn't,
relativity?
not in, I don't know if I would call it pressure, but there's a certain stress there. Yeah.
Okay, so you believe that there's a universal medium
Yeah.
and that the mediation of energetic exchange between objects in the medium and the medium causes density. Well, that would mean if it was density, it would be a buoyancy effect. Basically, the amount of medium that they're displacing,
Yo,
or
Pizio.
the volume of the medium they're displacing is how much buoyant force they experience. What's up, Alan?
Pizio, you're getting petered. He's literally not even talking about that. But now that
What's he
you've
talking
given him something to anchor onto, he'll just be like,
Okay.
"Oh yeah, that's what I'm talking about." But like, yeah, he's like not saying anything.
I gotcha.
Yeah.
Dude,
I was actually going to respectfully respond to the previous guy,
Nah.
but no, I don't think it's that. I don't think the medium is displaced in that sense, that it needs to make room for the things that displace it. I think that when I talk about the medium, I mean the thing in which things like air or water exist or are suspended. It's like the substrate for those media that we typically consider.
You sound like you're hinting at a non-physical medium.
I think it's absolutely physical.
Yeah, like an ether is what you're talking about.
Whoa, yeah, on the curse words. Ease it down, calm down.
No, I'm not that attached to a particular name for it. It's more, I'm trying to feel my way around what its properties are and how it interacts with what we would call physical matter.
It's a primary substrate.
Yeah. It's like
Okay.
a primary substrate in which all physical things like, I don't know,
Subsist.
my body, water, a piece of metal are kind of suspended in it, I would say.
Okay. Okay. What if those bodies, what if matter is made of it?
That I don't have an opinion on yet because the papers I've read don't suggest that. So it'd be
Okay.
kind of a speculation, I think.
Imagine this. All right. What you think of as matter is tiny bits of ether that have been flung off into extreme whirls of velocity in a particular pattern, like a toroidal shape. So they're spinning, but they're not spinning just like a little orb, but they're spinning like little toroid spins. Okay. And because they were put into that motion, whenever they were put into motion in that motion, like, who knows when that happened, but when it happened, because of that velocity, that spin rate, they are able to keep their form. Okay. So they maintain their shape. They hold rigidity in 3D space because of their, centripetal forces from their spin. And this gives them mass. So matter is actually made up of this substrate.
I mean, I see some similarities if I read in between the lines to what you said, between that and what I think it might be, but I think you've made a bunch of claims that I wouldn't feel comfortable substantiating myself. But some of it sounds close to how I am understanding it, especially the thing about the mass. Does it have to be toroidal? What is this fetish about toroidal things? Where does that come into?
Apparently I'm getting petered, but it's okay because, there's other people here too, right? But that's the natural geometric expression of the magnetic fields of tiny, tiny, tiny things.
Okay.
Just because David LaPont figured out, like, say, the double slit back in 2015 when he envisioned atoms not as little particles of balls bouncing off each other, but as big fields, right? And he had overlapping 3D double bowl toroidal fields. And he's like, oh, well, the double slit experiment when particles can't interfere with themselves, but if you have giant overlapping toroidal fields with constructive interference, then behold, a particle interferes with itself. You have the double slit, you have the particle, no dual wave, no particle dual duality. It's all understood. So all you got to do is envision it as a giant 3D toroidal field, and it works. Right?
Well, that was all done way earlier than 2015 without introducing any ideas involving toroidal shapes.
Oh, by them saying that the atom exists in, or the photon exists in two different places at the same time and interferes with itself and recombines into one singular location after the interference has happened?
I didn't say that because that's retarded, Peter. Did you want to say that? I'm sorry.
I mean, is that what you're talking about, Peter?
Yeah.
Yeah, okay. Well, we're not retarded, so we don't believe in that.
Okay, well, I'm not saying I agree with everything you proclaim. I'm just, there are some similarities.
Yeah, the Copenhagen interpretation is literally a comic book for children and adults who still have childlike sci-fi fantasies.
Believe in Santa, Spaceballs, etc.
That's crazy.
That must be really embarrassing to all those quantum physicists over the last 100
I mean,
years.
if you believe that
You'd be
light is made,
surprised.
hold on. Wait. If you believe that light, which we know demonstrably and observably, testably, repeatably is a wave for a fact. I mean, it's a wave. It is an analog continuous function that we can observe with any equipment in the world, and it's always like that. Okay, it's a wave. If you're going to say it's made up of a stream of an infinitely discontinuous stream because it's made up of particles, point particles. Okay. Then I'll go ahead and touch the double slit, and then I'll touch just why in general it's ridiculous. Then on this double slit experiment, you say, oh, I'm just going to measure one tiny bit of light, one photon. And how do I explain then this pattern? Because unless I have the photons going at the same time, there's no way it can interfere with itself unless it was waves. But they say, oh, wait, we can take the photon just before it enters the slit. It splits into two different places at the same time, and it goes through both slits. And then after it passes through the slits, it recombines into one physical location again and continues on, and it produces self-interference that creates interference patterns on a wall in the back, even though in reality it's just one little stream of particles hitting the wall.
Yeah, that would be very stupid to say. I agree.
Thank you.
Okay. Well, that is the Copenhagen interpretation, the standard model of particle physics interpretation of the double slit experiment using photons. So that's a problem.
I don't think so.
But
not according to my research.
No, you just had it explained to you, right? You agreed it was retarded, and then we told you what it was, and you were like, "Oh no, but I believe that, so that can't be right."
Yeah, he
No,
just
that
said
I
it was
don't believe at all.
ridiculous. Like there's no.
I don't believe that. I agree with you. That's stupid.
Okay, so you would be surprised if that's the standard explanation in the standard model?
That was perfect. Dude.
I would be shocked if the standard model claimed that light is a wave comprised of tiny little particles. Yeah.
Well,
you don't know about photons?
I do.
Wave particle duality?
Yep.
Albert Einstein?
And many others, yeah.
Okay, so you're just... What is the mainstream explanation for the cause of the double slit experiment utilizing photons? Go.
It is that the particle itself, its location and momentum are defined by a wave function.
So physically in reality, where is the photon when it's passing through the slits?
It's nowhere.
That makes more sense, you say.
Do you just like you're in court? That's the whole thing. The lawyer came out. The jury's out. PCO got him, dude. It's over.
I just got one more question, Your Honor, and then that was it. Guilty. Lock him up. See you, Peter.
The conviction with which he speaks, dude.
He was like, aha! Dude, like
Aha!
the Scooby-Doo unveil.
What do we have here? Oh, it's always J mysticism again. And if it wasn't for the J's, I would have had you again.
Yeah, the other problem with photons, there's more problems. Let's continue talking about how ridiculous photons are for a second.
Hold on, real quick. To an atomist, a photon, right, is a purely quantum mechanical object representing the smallest piece of energy, an elemental particle, also a minute energy packet, a massless, no electric charge, but always moves at the speed of light particle. Also exhibits wave-particle duality with its behavior, of course, both simultaneously exhibiting properties of waves and particles. And when it's detected, when you're looking at it or thinking about it hard, it registers as a single particulate unit that acts in a point-like manner. But in contrast, really, in reality, right, it's a wave. It exhibits properties of a wave. It propagates like a wave. It needs a medium, right? It has theories and waveforms that responds to everything calculations. You get energy of a wave, but who cares about that? Go ahead, PC.
Yeah, not to mention the fact that, quantum mechanics came from Schrodinger's wave mechanics. They took Schrodinger's wave function, which he invented and created and was awarded for, and told people that it was a real description of physical reality. He provided a means and a mechanism to explain physical phenomenon, which is what he was awarded for because it was successful in predicting the values in that physical phenomenon. And then they co-opted it and hijacked it and said, hey, if we just take your wave function and we square it, we can say it's not a wave, it's just a scatter plot of a bunch of little points everywhere. And that's what they did. And he made fun of it. That's what Schrodinger's cat was. People tell it now, they co-opt it as well in universities and say that Schrodinger was like this amazing explanation of how mysterious and awesome that quantum mechanics is. Dude, no, Schrodinger was baking on them, dude. He was over here roasting them. He was like, listen, dog.
It was satire.
Listen, dog. You want to know how dumb quantum mechanics is? Let me tell you real quick. All right. This is how retarded quantum mechanics is. If you were to have a cat, y'all like cats, right? You got a cat? Anybody got a cat? Oh, you got a cat? Okay. So my student over here, you got a cat, right? All right. So if you take your cat and you put it in a box, and you just lock it in the box. All right. You can't see the box, no windows, none you can see. You can't detect it in the box. This is a closed off box. And when you put it in that box, you ain't gonna feed it. You're not gonna feed your cat. I know it sucks. It's a nice cat, but you don't feed it. And after about, let's say, a week, you're gonna come back to the box. Now, before you open it, you ain't opened it yet. You don't know what's in it. You don't know whether that cat's alive yet. You don't know whether that cat's dead yet. What's your guess, Alan? You think that cat's alive or dead after a week?
Ooh,
I would love to hear people do
What
this
was the
description while drunk. That would be awesome.
You think a week's enough to kill it? You think it's gonna be alive or dead after a week?
I think it's dead.
You think it's dead after a week, Shane? What about you, Nicholas? You think it's dead after a week?
Is it an airtight box?
No, it's got an air where it can breathe. You just can't see in it. It's got this like magical barrier where you can't.
Got air, man. It's possible that it could be alive after a week.
Okay, so it might be live, but Shane thinks it's dead. All right. Y'all want to know how quantum mechanics would explain it? Just so you know, the cat is the particle. The cat's the particle, all right? Quantum mechanics says it's not that it's dead or alive. It's actually right now, as we sit here talking about it, it's over there in the box. It's dead and alive at the same time.
Damn.
Oh, man, my mind.
And it doesn't become one of them until you look.
And it's not until you open the box that it dies.
Oh, that's so majestically intellectual.
I think I've seen that movie. That was called Pet Sematary, right? With Stephen King?
I think Schrodinger
Peter, this is what you're defending right now. This is what you're defending when you say that you believe that it's not in either place. The photon, the slits. Where's the photon, Peter?
Give me the photon, Peter.
It's nowhere.
Hey, you think that makes more sense than a wave?
Guys,
It took human beings 100 years to realize that was the case.
All right, Peter, I don't want you to talk to me anymore. That's enough.
That was perfect.
I tell you.
Dude, I like how you set him up to tell him, like, you know how, let me tell you what you believe, right? Without telling him that he believes this. And he's like, yeah, I agree. Objectively, that's retarded, right? And then he's like, cool, great. But actually, that's the name of that thing that's retarded is what you believe. And he was like, no, wait, hold on. You tricked me. No, that's not. You know what? I don't believe. I double back and take my answer back. I rescind
Ladies and
it.
gentlemen of the jury, this has all taken place before you on the court of the internet. You have been witnesses.
It was beautiful, guys.
What is your verdict? Is Peter innocent or guilty of scientific perjury?
Scientism. Is he a scientismist or what?
Maybe a little bit of unfounded belief, but that's about as far as I'd go.
Peter did say that he didn't agree that that's what was happening and that it was dumb. I was like, you know, it's in both slits at the same time and interferes with itself. He's like, that's retarded. And I was like, okay, what's it doing? Oh, it's nowhere.
Yeah.
Oh,
1 second, boys.
okay, Peter.
1 second, lads. I just realized we're prosecuting Peter without proper defense for him. Ralph, we're going to need you to step in as Peter's attorney.
No, Peter can self-represent. That's totally
that was
fine.
a terrible decision. Overruled.
Peter, I do not recommend, Peter, that you represent yourself. Do you know your rights?
I do, and I choose to represent myself. No offense, Ralph.
See, there
You're
you go.
so far gone, buddy.
Oh, man. All right,
Some
well,
globular division.
That's good enough for me. Peter, I can't help you. I'm sorry.
Dude, to be honest, right, I thought I believed in photons and atoms too until I heard, right, that there was another alternative. I was like, wait, what is it that I believe? Infinitesimal particles, action that, oh my God, massless, has no charge, pops in and out of existence, infinitesimal packets, continuous stream of nothing that exhibits wave. Like, wait, what's the alternative? You know what? Doesn't matter. I'm on that team. Put me on the other side. Is there anything else? I'm in. This is retarded.
Yeah. The discontinuity. That's I got sidetracked. There's so many problems with photons. I try to explain one and there's another one pops up and I'm like, bam, I gotta shoot that one first, dude. Dang. All right.
Can I share one of my favorite quotes that I discovered
Yeah,
recently?
hold on. Yeah, 1 second. Let me finish this, Peter. So if you have a stream of photons that's drawing and tracing this sinusoidal waveform on my oscilloscope. I got my oscilloscope and I'm measuring this current, right? Then if you're telling me that sinusoidal continuous waveform that I'm measuring with this analog device is actually made up of point particles, so just hold on. No definite size in 3D space. 3D space, aka physical reality that we live in, okay? No definite size. It means they're sizeless because they're points. Because if you're on a graph and you define a point like 0, 0 on the XY axis or 1, 0, and I say, how large is that point? What's its area? What's the area of that point? Well, you don't have a left and right limit. The left and the right's 1 and the up and down, the up and down's 1. So like everything's 0. It doesn't have a size, okay? So that's why they say it doesn't have a size, because it's just a point on a graph. In physical reality, there's no such thing as a point. You can't have something that doesn't have a size.
That's true.
It? So, but anyway, in order to use points, how many points would you need between 0 and 1 to draw a line? If they're infinitely small.
In geometry or in reality?
In reality. If they're infinitely small, because when you draw, if you put ink on that piece of paper, if you draw a dot with a piece of ink, that dot has an area. That's not like a point. That's like just we estimate it as a point. You could put infinitely many points between 0 and 1. So if light is made of photons, they're point particles, you would need an infinity of photons to make a continuous function, to make a wave, to draw a line.
That's not that many.
Yeah,
and
but
if every photon has energy, if it's non-zero, which every photon has energy, because that's like the part of the definition of a photon, then if you have an infinity of photons and everyone has a little bit of energy, you have infinite energy. Every stream of light everywhere in the universe should have infinite energy. Well, that's
Yeah, that's not
obviously
the,
not real.
that's
So
not the case.
yeah, that's obviously not the case. I know.
Yeah,
That's what I'm telling
obviously.
you. And
That's
so
why we
that's
call
why
it
light can't be
quantum.
made of photons, Peter.
That's why we call it quantum. Yes, you got it. You nailed it.
Light cannot be made of photons.
That's why we have quantum packets of energy instead of a continuous distribution. That's
If you're
exactly
gonna
what quantum
Quantum
mechanics
discrete
is.
packets. He just
yeah, hold on. If you use the word quantum, then you are saying light's made of photons.
Yes, and the reason why we realized energy travels in quanta of energy is because we discovered there is no continuity in the underlying smallest substrata of nature, if you will. Substratum should be singular.
Substratum?
That was yeah. Well, oh, thank you. That was the realization that brought about the quantum revolution that's lasted for over 100 years now.
Let me explain to you the
That
cause of that.
realization alone turned over the classical mechanics, and it's been fundamental ever since. So you nailed it.
Yeah. So
Now, can I
know the
cite my
actual
favorite
reason?
quote?
You want to know the actual reason that they try to say that they know photons exist? Do you know the reason?
No,
Peter?
I don't. I've done my own reading on the subject. Thank you.
Okay. Well, I can explain it to you because I know the answer.
Please.
So you have this equation, E equals HF, okay? And it's called a Planck relation, the H, but it
That's a
explains,
constant, Planck's constant, you meant to say.
yeah, and it creates it has a relationship, like the
Yes.
relationship between them. So
And what
anyway,
are those things? What are those things in the equation? Walk us through it.
dude, I would explain it to you if you'd stop interrupting me every time I try to talk.
I'm sorry, I speak too much.
I'm noticing. So E equals HF. E represents the energy of a photon. It is claimed to be the energy of a photon. One photon. Got it.
Doesn't have to be a photon.
It is determined by HF. Okay. Now, H is a constant. It's joules times seconds. And F is frequency. It is measured in hertz. It is cycles per second. Okay. Now, when you write out hertz, they give you the SI units to use is 1/seconds. Okay. One is said to be unitless, but it's actually cycles because it's the repeating of something. So the frequency with which something repeats. Now, if you use this, you can actually count how much energy you will have in a stream of light. But if you use it, what is H representing in physical reality? Because I know what F is. F is how many wavefronts I have hitting a point in space in 1 second. It's the frequency. If I have 10 hertz, then that means I have 10 wavefronts smashing within 1 second. So what's H? H is, ready? They say it's just like, this number they derived by measuring it, or calculating it with black body radiation, and we're applying it to photons. But you know what makes way more sense than just making stuff up? Light being a wave and H representing each peak trough, the wave crest and the wave trough. You got the top and bottom of each wave, makes like a little egg shape if you put them together. H is the number of wavefronts. And because we know it's a material, and I'll tell you the reason, but we know that there's this conjugate inverse relationship between frequency and wavelength. And so electromagnetic radiation, like the frequency wavelength of light, actually is inverts. If you increase the frequency, the wavelength gets smaller. As it gets taller, it gets skinnier, and as it gets wider, it gets shorter. So, but that's actually a material property of the medium. It just constricts it like that, most likely. But if you count the number of wavefronts, you'll know how much energy you have. See, that's what I think is amazing, is when you have a wave, you can actually draw something out and describe what it would be physically, because it has meaning. It has demonstrable meaning. We can observe stuff like this. But when you talk about virtual particles that you invent because you need them to exist, because you want to describe everything on a graph with points, and you say the points actually represent physical entities instead of measuring physical entities and defining them that way, then you get into this la land where they are now, where they say that, there are literally virtual fields and virtual particles that pop in and out of existence instantaneously, so quickly that you can't observe it or witness it because it happens instantly with no respect for time. But we know that it must be happening because our calculations were wrong, and when we measured it, we were off. That's why virtual particles exist, by the way, just so you know. All the different virtual particles represent deviations from energy predictions or magnetic moment predictions, etc., that they had made. And they said, oh, the reason we must be off, we're always off by a factor of this. Well, there must be a particle. There's a particle somewhere. And since we can't measure it, it just must be a virtual particle.
So much to unpack. Where do I start? Let's start at the beginning. So you said the equation was E equals H times F.
Uh-huh.
And then you started telling us about the meaning or the proper meaning of H. H is a constant, and in physics, constants are just used to represent the proportion between units. For example, let me ask you a question so I don't talk too much. What would be wrong with the equation E equals F? Can you explain?
Yeah, because F is not a unit of energy, Peter. I don't need you to try to instruct me in basic units. I need you to
And what if the value of H we took as 1?
Then you would have 1 joule per hertz.
So we would have to adjust our units basically so H can equal 1, right? These units are arbitrary in the first place. They're usually chosen at some point in history, and then we stick to them for consistency. And then we introduce constants that map from one unit to the other as we learn about true nature of reality. So H is a constant that allows us to map between one unit that we customarily use, like a second or a hertz, and energy. There's no other meaning to them. It's the same goes for the big G, by the way, that you guys like.
No, Peter, it has a physical meaning. It's a
Yeah,
physical
it does.
equation.
The meaning is we have certain units describing a certain physical reality. We're used to them. We want to keep them. Now we have to map them in proportion to the other unit as we discover new relationships. And H is there. You can choose a different system of units in which H will have the value of 1. So there's nothing there.
No, Peter, you're saying that there's nothing there. You're denying. If you say that, I don't know if you don't realize this or don't understand this, then you're denying
Energy equals frequency. That's what you need to know.
Energy has a proportionality to frequency, but
Which means it's the same as frequency. It's like pounds and US dollars. The same thing is there's a certain proportion, assuming, not non-fluctuating currency rates, certain proportion, one buys you the same, iPhone, you just multiply by the ratio to translate into another currency. That's what H does. There's nothing to it. Same goes for the big G that you guys like to obsess about. So if you don't get that, that means you don't understand the meaning of these equations and what constants are for.
Oh my gosh, Peter. H.
You know what?
This is the equation for the energy of a photon. If you're denying that this is like what they claim, Peter, then you're just denying the standard model. And if you're not debating like our model with the standard model, then I don't know what model you're using, and you need to define it, and you need to explain what you believe in and why it's not what the mainstream teaches and why it's also not what we're talking about. I mean,
Maybe
like,
we can just agree that we've done slightly different research on the subject.
No, Peter, watch me. Ready? I'm going to show you a masterful trick I've been learning from Witsy. Watch carefully. Hold on. You know what? You're probably right.
Thank you. Now, can I share my favorite quote that I learned
We're
recently?
good. Oh, I'm just kidding. If you want to share a quote, go ahead.
The quote is, nature cannot be fooled.
Great.
isn't it wild, Shane, how you can like talk to someone, right? You can explain to them this ridiculous